Hello, hi, namaskar everyone. Give me a quick response. Am I clearly visible and audible? Can you all hear me? Can you all see me? I hope you can see the title right there in front of you. Inverse Trigonometric Functions in One Shots for IT JEE. That's what we'll try and do here. As we all know and believe that in one shot, you cannot study a chapter totally, especially for JEE. And we also agree with this. We totally agree with this. But what is the motive of these one shots in that case? These one shots will help you in understanding the concept, the theory, and of course, with the decent amount of examples. But sir, if we really wish to crack JEE Mains in advance, are these one shots enough? No. With these one shots, we'll highly recommend you to solve a lot of questions, a lot of apt, appropriate, and relevant questions, which we usually give in our DPPs and all in our batches. But here, I'll request you, everyone who's watching this video, who's watching this one shot and believing that I want to consolidate this chapter, I want to score really well from this chapter, then do one thing. JEE Mains PYQs of the last 6 years. Don't skip any of those. After watching this one shot, solve all those questions. That's exactly what we are trying to do, Gaurav. Even if you want the revision, you can. Along with this, do remember that once you are comfortable with the mains PYQs of the last 6 years, let's say, then go to the advanced PYQs of last 20 years. Shall we get started, everyone? Can you all hear me? Can you all see me? Before we start, you know that Pylons is an amazing feature which we have launched through which you can participate in the polls conducted by us. So if you are going through a question and if I ask you to participate in that poll, you can participate in it. You can download this Pylons application from Google Play Store, or if you're watching it on this desktop or laptop, you can download it from Chrome Store as well. This Pylons not only helps you in participating in polls, but with this feature of Pylons, any random video, let's say you're watching on YouTube, you can generate mind maps, short notes, previous year's questions, quizzes, and a lot of things related to that video with the help of this amazing tool, Pylons. Good evening, good evening, good evening, everyone. Good to have you all. Why are you not attending the class? Recap of the previous lecture. What kind of recap I can give you? So far, I hope you have gone through the one shot of the determinants. So far, we have gone through the one shot of matrices. So far, we have gone through the one shot of relations and functions. Technically, it wasn't a one shot, it was two shots. I mean, functions part 1 and part 2. We released 2 parts on this. So we covered it in that manner. Remember that, everyone. I hope you do remember that in these one shots, we again tried covering these chapters. So my humble request is, after watching this session, if you haven't watched any of these and if you want a good revision of those, you can definitely watch these one shots as well. Now, if I could try and tell you what all we'll be covering today, I'll start with the basics of ITF. I'll tell you that why these ITF exist, what is the reason, and why do we deal with them. And with all those restrictions and everything, we'll start exploring a lot of properties, property number 1, 2, 3, 4, and so on. And all those properties, formula relevant questions will do and consolidate ITF with this one single session. Shall we get started, everyone? If you all can hear and see me properly. I hope you do remember that when we look at trigonometric functions, when we look at trigonometric expressions, I hope you do remember that when we look at trigonometric functions, the graphs, when you notice, I hope you do remember that when you notice the graphs of sin x, cos x, tan x, any function if you notice, you would notice one very beautiful thing happening over there is that they are many to one. For example, if I show you a very random one, if I could show you a very basic one, let's say if I draw the graph of y is equal to sin x, right? So what happens with sin x is that it is clearly a periodic function. It is clearly a periodic function which takes values between -1 and 1 in terms of its output, in terms of its range, and it keeps on hovering between -infinity to infinity on the x-axis. So in terms of domain, it is from -infinity to infinity, but in terms of range, it is from -1 to 1. I hope you all got that, yes or no? But before I begin with this, I am recalled to tell you that we are going to reveal something really exciting and amazing tomorrow. Tomorrow, I think around 5 p.m. Tomorrow, that is 16th of July. Can you tell me in the comments, what do we mean by GOAT here? Who is GOAT or what is GOAT here? So I'm supposed to tell you this feature this exciting, amazing thing which will be revealing or releasing tomorrow regarding or related to something related to GOAT. So this will be launched tomorrow. So if you haven't explored it yet, which you cannot because we haven't revealed it yet, so tomorrow we are coming up with this exciting feature, right? Now coming back to Desmos, here we are. Pay attention, everyone. We know that all of these trigonometric functions, sine, cos, tan, cosec, sec, cos, they all are many to one. They all are many to one. So if a function is many to one, and if I wish to define its inverse, can I really define its inverse? Sir, as far as inverse functions are concerned, I'm not talking about inverse trigonometric functions. As far as inverse of a function is considered, you need two things. Which two things, students? You need two things. The two things specifically are 1, 1 and onto it should be. 1, 1 and onto it should be. I repeat, sine, cos, tan, cosec, sec, cot, they all are many one. So first of all, there is clearly a violation here that if they all are many one, you cannot define their inverse. That's first problem. Second problem, let's say even if I ensure that they are onto. Sir, how do we ensure that it is onto? Sir, if x-axis minus infinity to infinity, then what is y-axis? On y-axis, sine ranges between -1 to +1. I come back to this. Pay attention, everyone. Here we are. I am telling that sine, cos, tan, cosec, sec, cot, they all are. Yes, they all are many to one. So if I wish to ensure that I can find their inverse, how can I define the inverse of a function which is many one? Because if I swap the domain in range, it will become one to many. Many one, when you try to find its inverse, it will become one to many as a relation, and one to many, of course, is a relation, but it cannot be a function. Yes or no? Yes or no? If I could try and tell you this, let's say I am defining y is equals to sine inverse x. This is how I'm writing it. I am given a function, let's say f of x is equals to sine x. Now what I'm trying to tell you is that let's say for 30 degree, you say the value of sine x or sine 30 is 1 by 2. Yes, it is true. Even for 180 minus 30, that is 150 degree, the value of sine is still 1 by 2. Okay, sir, it is fine if it is one to many, sorry, many to one. But if I wish to define its inverse, if I'm more interested in y is equals to sine inverse x, then what's the problem? I hope everybody is clearly realizing the problem that inverse means what? Inverse means what? If I'm now dealing with y is equals to sine inverse x, so the problem is this codomain becomes the domain. So here I'll have all the values between -1 and 1. And this domain will become the range or codomain or part of codomain. I hope everybody is very clearly noticing that if I ask you to take sine inverse of 1 by 2, what is the meaning of sine inverse of 1 by 2? It means I'm looking for an angle. I'm looking for an angle whose sine ratio when you take gives you a value 1 by 2. Are you able to process my language? What did I just say? I said that I'm looking for an angle. Sine inverse x, what does it produce as an output? An angle. So I'm looking for an angle. Sine inverse x is technically an angle. Which angle, sir? An angle which when given an input 1 by 2. So this x will be the input 1 by 2. So I'm looking for that angle whose sine ratio when taken gives you a value 1 by 2. But sir, if you take it like this, or if you think it like this, will you not say that so there are multiple angles because sine, cos, tan, all these functions are periodic. They are many to one. So if I look at 1 by 2, I will get infinitely many values for which if I take their sine ratios, it will give me 1 by 2 as an output. So sir, there is a clear problem here. What problem? The problem is that you cannot do it like this. I think we are making a mistake. What mistake? Sir, many to one they are. I think that's the whole problem. So if I could make them 1, 1 on 2, if I could make them 1, 1 on 2, if I could make them bijective, yes, Aditya Kumar, if I could make them 1, 1 on 2, if I could make them bijective, then I'll be able to define their inverse. How? Let's talk about sine x. If I talk about sine x as a function, so this is y, this is x-axis, this is y-axis, and here I'm drawing the graph of y is equals to sine x. So its graph goes between minus infinity to infinity on the x-axis. What if I restrict it? Sir, what do you mean by restricting it? What if I restrict it between minus pi by 2 to pi by 2? Sir, what happens then? Let me show you first. Between minus pi by 2 to pi by 2, if I restrict it, this is how the graph will be drawn. Yes or no? This is how the graph will be drawn. Although after pi by 2 it will keep going like this, before minus pi by 2 it will keep going like this. But what if I restrict it here between minus pi by 2 to pi by 2? What is the advantage here? The advantage is pretty simple here, students. Are you noticing one very crucial, important observation, that here I have gotten all the values from -1 to 1, which means I have ensured that it attains all the values from -1 to 1, which means it attains all the values in its range. Because I am taking those numerically smallest possible angles so that I could produce all the possible outputs of sin x. So if I try the values of x between minus pi by 2 to pi by 2 around Francis, I will ensure sin x takes all the values from -1 to 1. By doing so, by restricting this x between minus pi by 2 to pi by 2, I have ensured that sin x still takes all the values from -1 to 1. But here in this case, I have now ensured that the function now is 1, 1 and on 2. How? I am defining this function f from minus pi by 2 to pi by 2 to -1 to 1. I hope you know how to read it. If this function is defined as sin x. So what does it imply, students? This part here tells you the domain. So x will take the values from minus pi by 2 to pi by 2. That part I have restricted. And this part here tells you the codomain. Codomain means all the possible values of y could be from this set -1 to 1. Now, if I'm restricting it between minus pi by 2 to pi by 2, and if I'm talking about its codomain is -1 to 1, now you tell me, is it not 1, 1? Sir, it is indeed 1, 1. Why are we saying it? Because if I do a horizontal line test, wherever I draw a line parallel to the x-axis, it will not intersect this curve more than once. So if these lines are intersecting these curves at exactly one places, I think I am in a very strong position to claim that this function is clearly 1, 1. Everybody got it? So sir, first of all, by doing so, we have ensured that this function is clearly 1, 1. This function here is clearly 1, 1. Okay, we got it. But along with this, can you help me with its range as well? Sir, when you talk about its range, sin x for all the values between minus pi by 2 to pi by 2 takes values from -1 to 1. So if I ask you its range, will you not say, sir, we have just figured out its range. It is lying between -1 to 1. So if codomain and range are same, we call it onto. Remember that 1, 1 means injective, onto means surjective. So if I ever notice a function which is injective as well as surjective, what do I call it? Can you help me in the comments, students? A function which is injective as well as surjective. A function which is 1, 1 and onto. I hope you do all very clearly remember that a function, if it is 1, 1 and onto both, we call it 1, 1 onto, that is bijective. Remember that, students' idea? And if a function becomes bijective, the whole point becomes very clear that now I can define its inverse. Everybody got my point. Everybody understood my point. Everybody with me so far without any confusion or hesitation. Tell me honestly, are there any queries or concerns? If there are any, do tell me, do let me know. Shall I get started? Shall I resume? Everybody, let me read the comments. Yes, it is indeed bijective. Good, Harshit. So that's my whole point. If I could restrict it in a certain domain, I would ensure that it will become bijective. And if it becomes bijective, my job is done. My job is totally done. I can define the inverse of this function. Not only the inverse of sine, but I can define the inverse of cos, tan, cosec, sec, cot, all. Here comes the inverse of sine. Pay attention, everyone. Excellent, great. With this, pay attention, everyone. Here we are. The graph of sin x goes like this. Between minus pi by 2 to pi by 2, it stays between -1 to 1. But if I wish to draw its inverse, how do we draw its inverse? So to draw its inverse, the domain which was from minus pi by 2 to pi by 2 will become its range for sin inverse x. And the range which was -1 to 1 for sin x will become the domain for sin inverse x. Able to process this idea, students? And in relations and functions, we have learned this amazing fact that if you wish to draw the graph of inverse of a function, do nothing but simply take the mirror image of that curve in the line y is equal to x. Remember that? So if the curve sin x looks like this, if the curve sin x looks like this over here is the line y is equals to x, this over here is the line y is equals to x. And if you take its mirror image, if you take its mirror image in that line, where will it go? Will it clearly not go here? So this graph here, this curve here is your sine inverse x. Everybody got it? Everybody comfortably understood it? Yes or no? Shall I repeat that part, students? Yes or no? Everybody comfortably got this idea? So if I could go back and tell you how do we draw the graph of sine inverse x, I hope you have crystal clear clarity on this part that sine inverse x, if I wish to draw its graph, of course, y-axis, x-axis. But here in this case, please pay attention everyone. Now we are more focused on sine inverse x. So please pay attention everyone. Previously when we used to discuss y is equals to sine x, in that case this x used to be the angle and this y used to be the value. Value means what? The angle you pass to sine and you take its ratio and it produces an output. Yes or no? Yes or no? With this, if I am taking its inverse in this case, I hope everybody is realizing this x is not an angle anymore, it is the value. And this y over here is going to be the angle because it is inverse now. Everybody got it? Yes or no? If you rewatch it from the beginning arrow, you will understand it. Don't worry. Here we are. I hope now it makes complete sense that, sir, on the x-axis, you will not take minus pi by 2 to pi by 2. You will take minus 1 to 1 for sine inverse x. Yes or no? Because the range becomes the domain becomes the range. Swapping. And here, if I talk about the values minus pi by 2 and pi by 2, they used to be there on the x-axis, but they'll be on the y-axis. I hope you are clearly getting this statement. With this, if I try and draw the graph, I hope it makes complete sense that here at pi by 2 sin x is 1, at minus pi by 2 sin x is minus 1, and at 0 sin 0 is 0. But we are looking at it from the inverse functions perspective. So what will I say? I'll say sine inverse of 1 is pi by 2, sine inverse of 0 is 0, sine inverse of minus 1 is minus pi by 2. And that's how you'll be drawing its graph. Everybody comprehended it? So when I wish to define it, y is equals to sine inverse x, I clearly restrict x, of course, between minus 1 and 1 because sine inverse is taking certain input. Now this input is not an angle anymore, it's a value. What value will it process? Sir, it will be able to process all the values between minus 1 to 1. So I hope this part is very well digested by you that when I talk about y is equals to sine inverse x, this x has to lie between minus 1 and 1. Sir, what does it mean? It means, let's say, if someday I ask you, someday if I ask you, what is the value of sine inverse 3? What will you say? Sir, sine inverse 3, this is 1, 2, 3. Ahead of this, I'll have a 3. At a 3, the function doesn't exist. The function sine inverse x technically exists between minus 1 and 1 only. So sine inverse of 3 does not exist. Got my point? Is not defined. Yes or no? Everybody getting it? Yes or no? This part. So first of all, you need to understand that sine inverse x can take inputs as minus 1 to 1. And when I talk about the output, the principal domain which gets converted into range here, so the values of y, the values of sine inverse x will clearly lie between minus pi by 2 to pi by 2. So in inverse trigonometric functions, the graph is defined in such a manner that we take the numerically smallest possible value. The angles which we are considering here, those should be numerically smallest possible. What did I just say? I said that here, let's say sine 1 by 2. Sine x is 1 by 2. I could produce at two values. Sir, which two values? I said that sine x is 1 by 2. I could produce at 30 degree as well, 150 degree as well. Not just that, even for some smaller angles, negative angles as well, even for some greater angles as well. So I here had a lot of choices. But what did I preferably choose was this 30 degree. So for ITF, the principal domain we define of these trigonometric functions will be the numerically smallest angle. Did you understand this language? Let's say if I ask you root 3 by 2. If I ask you root 3 by 2. So what I'm asking you is, let's say if I ask you sine inverse root 3 by 2. So sir, from trigonometric functions perspective, you say it can have multiple angles. But if you are calling it an inverse trigonometric function, so it should have a unique value. So what definition are we following here? What rule are we following here? What logic are we applying here? The rule is pretty simple, that I will look for the smallest possible angle. Numerically smallest possible angle. What does it mean? Pay attention everyone. Root 3 by 2. I hope you remember sine 60 degrees root 3 by 2. So for 60 degree, I get root 3 by 2. But do I get root 3 by 2 for some other angles as well? Yes, I do. I hope you remember not just 60 degree, but at 120 degree also we get root 3 by 2, and some more angles are there in that series. And even some negative angles are also there. But sir, then what do we do here? I'll say, what is the numerically smallest angle? 60 degree. So I'll write either 60 degree or in radians, I'll call it pi by 3. Have I answered that query of yours? Everybody getting it or not? So I hope existence of inverse trigonometric functions is very well understood by everyone. Why do they exist? Why do we bring them in picture? And how do we define them? Everybody got it? Yes or no? With this part coming into picture, let's explore one more very crucial part where we will be defining all of these inverse trigonometric functions. Now, in our batches, what trick I tell, it's not a trick, it's merely an observation. I tell to the students to remember it, that sine, cosec, and tan stay on one side, cos, sec, and cot stay on the other side. What do I mean by that? Look at this. Sine inverse x, if I wish to define. So this x will stay between -1 and 1. Are you listening and understanding? Cos inverse x, if I wish to define, this x again will stay between -1 to 1. If I would show you, I could show you with this graph of cos inverse x. Please pay attention, everyone. Cos x, if I restrict between 0 to pi. If cos x, I restrict between 0 to pi. Are you noticing the graph of cos x here between 0 to pi? Everybody noticing the graph of cos x between 0 to pi? So between 0 to pi, if I restrict cos x, I will ensure that cos x takes all the values between -1 and 1. So previously, in case of sine inverse x, if I restricted sine x between -pi by 2 to pi by 2, here cos x, I'll be restricting between 0 to pi. Sir, why did you not restrict it between -pi by 2 to pi by 2? Why are you confusing us? I'll say, if I restrict cos x between -pi by 2 to pi by 2, you would see the problem. You would see the problem. If I look at cos x between -pi by 2 to pi by 2, cos x is taking values from 0 to 1 only. So am I getting all the values from -1 to 1? Of course not. Of course not. Aaron Francis, in that case, I will request you to go and watch the session on relations and functions. There I have explained inverse trigonometric functions and inverse function, and there I have explained that why do we take the mirror of a curve with respect to the line y is equals to x so that it gets inversed. I repeat, so if this is the line y is equals to x, with respect to it, if I take its image, mirror image, I hope mirror image you understand, this will give me the graph of cos inverse x. Sir, we don't get this concept. Can you do it in a little different manner, through some other method, through some other approach? Yes, we can do it. Here we are. Let's say here we have this as our y-axis. This here is our x-axis. Now please pay attention, everyone. Cos x we restricted between 0 to pi. So for cos x, that 0 to pi was on x-axis. For cos inverse x, it will be on the y-axis. So this will be 0, this will be, let's say, pi by 2, and this will be pi. And remember, pi is approximately 3.14. So scaling also, if I do, I'll take care of it. So what am I drawing right now is y is equals to cos inverse x. But here again, I would emphasize on the same thing, that sin x produces the output between -1 and 1. Cos x also produces the output between -1 and 1. So cos inverse x will take the inputs between -1 and 1. Is my language understandable, students? Are you able to process all what I'm saying here? I am saying all of this with the belief that you have already understood the chapter relations and functions. You know the basics of that. So whatever terminologies I'm using here, input, output, that thing, we have already covered in the chapter relations and functions. So they all are interrelated. So you cannot study a chapter independently. you'll have to understand all the previous chapters as well. So I'm sure you are comfortable with the previous chapters right now. Y is equals to cos inverse x if I wish to plot. I know three things here. Which three things are? Cos inverse x will clearly tell me that I will take inputs from -1 to 1. So I know this thing for sure that here, if I wish to define x, x will say, you can take my values from -1 to 1. Now we know cos pi is -1, cos pi by 2 is 0, and cos 0 is 1. And I hope it makes complete sense that here, this is how you will see the graph of cos inverse x coming into picture. I'll state the same fact again. If I ever ask you the value of cos inverse 1.7, what will be your response and answer? What will you say in that case? I hope you remember that cos inverse takes inputs from -1 to 1 only. It takes inputs from -1 to 1 only. And what about this 1.7? Sir, this 1.7 is clearly an input which is greater than 1. So can I really process this input? Of course not. Look at this one. Out of this, ahead of this one, on the right of this one, I'll be getting 1.7. At that 1.7, the function does not exist. It is not even defined. So I'll not define it, which means cos inverse cannot process this input, which means it is not defined, or I may say it does not exist. Able to, conceptualize it, able to digest it, able to understand it, yes or no, all the participants. The concept of ITF. Cos inverse, did you all process? So if you all could understand cos inverse, I will take you back to this part where we discussed that cos inverse also has inputs from -1 to 1. But when you talk about outputs, it produces outputs from 0 to pi. Everybody comfortably getting it? Now let's talk about tan inverse, everyone. So if I try and plot tan inverse, please pay attention, everyone. Do you remember the graph of tan x? Do you all remember the graph of tan x? If you do, I think you will be in a better position to understand the graph of tan inverse x. Sir, what do you mean by that? Please pay attention, everyone. Tan inverse x also, I will restrict between -pi by 2 to pi by 2. Although again, it's a periodic, so it keeps on getting repeated. The same pattern, which pattern, sir? This is the graph of tan x. This is the graph of y is equals to tan x between -pi by 2 to pi by 2. Remember that idea, students? So if this graph is reflected with respect to the line y is equals to x, I will get the graph of y is equals to tan inverse x, which means this line over here is representing the graph of y is equals to tan inverse x. But sir, how do we really draw it? Can you explain it in a more better manner? Let's go through that. I repeat. Let us get back to the generation here. How do we generate it? How do we understand it? How do we process it? So let me draw a quick rough sketch of tan inverse tan x first. So I hope you do remember that this is how we talk about y is equals to tan x. This is the graph of y is equals to tan x, where tan x stays between -infinity to infinity in terms of its range. So if I talk about the domain, of tan inverse x, it will stay between -pi by 2 to pi by 2. But if I talk about the range of tan x, it will take values between -infinity to infinity, yes or no? Everybody digesting this whole idea, or shall I repeat this part? Having said that, if I could try and plot the graph here, sir, the range which was from -infinity to infinity will become the domain. So this time, domain will be from -infinity to infinity for the curve y is equals to tan inverse x. And the range will be -pi by 2 to pi by 2, because -pi by 2 to pi by 2 is our principal domain. I'm restricting tan x between -pi by 2 to pi by 2 because in this, numerically smallest possible angles I'm attaining, and I'm taking all of the values of tan x from -infinity to infinity, yes or no? So with this, I'll say that, sir, if you restrict it between -pi by 2 to pi by 2 like this, I'll say this is 0, this is infinity, and this is -infinity. So that range becomes the domain becomes the range for inverse functions. So here we are drawing the graph of y is equals to tan inverse x. So of course, there will be a point pi by 2, there will be a point -pi by 2. So in terms of range, tan inverse x is going to stay between these two lines, yes or no? Everybody getting it? Tan inverse x is going to stay between these two lines clearly. I hope you're getting this idea, yes or no? So I hope you know that when x approaches pi by 2, 10x approaches infinity. When x approaches minus pi by 2, 10x approaches minus infinity. The same inverse logic I can apply here, that when x approaches infinity, tan inverse x will approach pi by 2. When x approaches minus infinity, tan inverse x will approach minus pi by 2. Tan 0 is 0. So that's how you draw the graph of tan inverse x. Everybody understood it. Everybody got it. Or shall I repeat it? Tell me honestly. Are you all comfortable with the graph of tan inverse x? Yes or no? All the participants. Have you all gotten it completely? All the parts I have explained so far. Does it make complete sense? Can I move ahead from here then? Okay, great. With this, if I again take you back to the table, so far, sir, we were seeing a problem that sine inverse and tan inverse as functions were clearly not taking any value beyond -1 and 1. They were taking inputs from -1 to 1. But tan inverse, in terms of taking inputs, is absolutely fine with any real number. Are you processing this thought? Are you processing this idea? Sir, here, tan inverse is defined for all the values of x, for all the real values of x. The graph exists from minus infinity to infinity everywhere. So I'll say in existence of tan inverse x is there for all the x. But again, as I've told you in the beginning, that sine inverse and tan inverse and cosec inverse stay on the same page in terms of range. What did you just say? I said, do you remember that sine inverse x also produced outputs from minus pi by 2 to pi by 2? The same is done by tan inverse x, that tan inverse x is also producing the outputs from minus pi by 2 to pi by 2 with a slight change, with a slight difference. What is that difference? For sine inverse x, the principal range is closed interval minus pi by 2 to pi by 2. For tan inverse x, the principal range is open interval minus pi by 2 to pi by 2. And I hope you understand this. It makes complete sense because at minus pi by 2 and pi by 2, sin x is -1 and 1 respectively. But at minus pi by 2 and pi by 2, tan x is not defined. So I'll be using open interval in its range. Everybody got this idea? Everybody understood this thought comfortably? Now, can I explain the remaining three in a little quicker manner? Cot inverse x, sec inverse x, and cosec inverse x. If you have understood the modus operandi, the SOP, how are we plotting the graphs? How are we drawing the curves? How are we looking at the domain? How are we noticing the range? The same thing I'll be doing for cot, sec, and cosec now. Shall we start doing that? Everybody paying attention here? So if I now focus on the next function, which is cot inverse x. So I repeat, cot inverse, if you notice, like cos, I'll restrict it between 0 to pi. I'll restrict it between 0 to pi. Sir, what do you mean by restricting it between 0 to pi? If I restrict cot x between 0 to pi, it attains all the values from minus infinity to infinity. It attains all the values from minus infinity to infinity. That's all about y is equals to cot x. Sir, but you are more interested in defining cot inverse x? Yes, have patience. So here, the principal branch which I took was 0 to pi. So for cot inverse x, this domain 0 to pi will become the range. Yes or no? For cot inverse x, I will be seeing the graph lying between, I'll be seeing the graph of cot inverse x lying between 0 to pi. But sir, one thing very beautiful you must have noticed is this, that here, that cot inverse x, I repeat, when you look at cot x, it existed from minus infinity to infinity on the y-axis, which means the range of cot x, was minus infinity to plus infinity. So this range here will become the domain there. So for cot inverse x, the domain will be from minus infinity to infinity, which means you will again see, just like tan inverse x, the existence of the graph from minus infinity to plus infinity. Able to get this idea, able to understand this whole process? Are you able to get this whole thing completely and totally? Yes or no, everybody? So what am I trying to explain here is a very simple fact that as long as cos and cot are concerned, of course, cos in terms of inputs takes values between -1 to 1. But cot inverse in terms of inputs takes inputs as all the real values. So sine inverse x and cos inverse x were behaving same in terms of domain. Tan inverse x and cot inverse x are behaving same in terms of domain. But I wanted you to see something differently here, that sine inverse x, tan inverse x, and cosec inverse x will behave same in terms of range. Not exactly same I said, but on the similar page, on the similar note. Look at the range of cot inverse x. I said cos inverse x, cot inverse x, and sec inverse x will also behave same in terms of range, if you are noticing. So I hope you do remember when we discussed cos inverse x, I told you very specifically that it lies between 0 to pi. Cot inverse x, as in range, lies between 0 to pi, but that is closed. I hope you remember cos 0 is 1, cos pi is -1. So it is perfectly defined between -1 to 1 to closed, and 0 to pi, I take all the values, closed interval. But if I bring cot inverse x into picture, I hope you are realizing it goes from -infinity to infinity. So it approaches infinity. I hope you remember it approaches -infinity and infinity at 0 and pi, and that's the whole thing here. That here 0 and pi will be open. Able to digest this statement. Now, how do we relate it? For sine inverse x and tan inverse x, it was minus pi by 2 to pi by 2, but sine inverse was closed, tan inverse was open. The same thing happened with cos inverse and cot inverse. Cos inverse and cot inverse both were having the range from 0 to pi, but cos inverse took closed interval 0 to pi, but cot inverse will take open interval 0 to pi. Are you able to make some sense out of it? And this very beautiful and interesting thing you all must have noticed, sine inverse and cos inverse both take inputs from -1 to 1, but tan inverse and cot inverse take inputs from -infinity to infinity. Sir, why are you emphasizing so much on these values? Why are we learning them with so much focus, with so much repetition? Why do we have to go through them time and again like this? Because this is the basic, the foundation of this chapter. Trust me, if you could understand this table, if you could store this table in your brain, half of the chapter will be done. Mark my words. Every single property which I'm going to explain further in the upcoming slides will be understood by you very quickly, very effectively, very, in a proper, thorough manner if you have this picture there stored in your brain. So I hope you're understanding my request, everyone. We are emphasizing more on this slide here. We are trying to understand and digest and learn every single thing here. If you could process this, all the formula and property, you will be able to understand very easily. Mark my words. Now, the two most critical ones, sec and cos. Sec and cosec inverse. The whole problem is, look at them. First of all, sec and cosec are reciprocal of sine, cos and sine. But sir, here we are talking about cosec inverse x and sec inverse x. So I hope inverse sign here does not mean that it is 1 upon cosec x. No, this and this are different. This -1 is not a power here. It is a symbol. It is a representation. It is a statement saying that you are taking inverse function. It does not mean 1 upon cosec x. I hope you're getting it. Had it been 1 upon cosec x, I would have called it sin x, and you are technically drawing y is equals to sin x, which is not the case, which is clearly not the case. Getting my point, everyone? Yes or no? So, sir, what are we doing in that case? I am saying that cosec inverse x, first of all, will deny any value from -1 to 1. I'm not talking about, forget it. Cosec inverse x, I'll draw later. Shall we talk about cosec x? Sin x, pay attention, everyone. Sin x says that If I talk about the values between minus pi by 2 to pi by 2, sin x says I will take all the values. I will take all the values from minus pi by 2 to pi by 2. Yes or no? Do you remember that? Sin x, do you remember that? But sir, sin x has a problem. It's not a problem, but it's an observation that at 0, sin x becomes 0. So at 0, if sin x becomes 0, cosec will be not defined because cosec is technically 1 upon sin x. So at all those points where sin is becoming 0, cosec will be not defined. But sir, we are discussing sin x between minus pi by 2 to pi by 2. So I'll restrict cosec also between minus pi by 2 to pi by 2, but I will not include 0. I'm not talking about inverse function. I'm talking about straightforward direct trigonometric function, cosec x. Cosec x, the principal branch which I'm going to take is from minus pi by 2 to pi by 2, but I will exclude this 0 if you could get my point. Everybody, yes or no? And for that, sir, we know the graph of sine. The graph of sine, I hope you do remember, goes like this. The graph of sine goes like this. This is the graph of sine. So this is the graph of sine x. Pay attention, everyone. This is the graph of sine x between minus pi by 2 to pi by 2. So graph of cosec x between the graph of cosec x between minus pi by 2 to pi by 2 goes like this because at 0 it is not defined. But based on that, if I try to plot or draw the graph of cosec inverse x, how will I do it? So I repeat, this part which I'm highlighting with a little different color, if you are paying attention to this part over here, this part over here, I hope you're noticing this part over here. This part, I hope it is very well understood by everyone. And this part over here, this part over here, this part. These two parts, these white lines, are the graph of y is equals to cosec x. Now, what does the concept say? Sir, the concept says, I hope you are very well, in a very focused manner, paying attention to the graph generation here. If you could understand this part, trust me, the job is done. For cosec x, the principal domain I took was from minus pi by 2 to pi by 2, excluding 0. So this thing will become the range for cosec inverse x. So if I'm willing to define cosec inverse x, this thing minus pi by 2 to pi by 2 will become the range. And the range of cosec x was what? The range of cosec x was minus infinity to minus 1 and 1 to infinity will become the domain of cosec inverse x. Are you able to process this statement, everyone? Does it make some sense without getting confused? So here, one idea is really simple. You just draw the reflection of the curve cosec x, which is the white one, with respect to the line y is equals to x, and you will be done with the graph of cosec inverse x. That's a very beautiful idea, which you should use. But let's say, sir, I don't want to get into these kind of complexities. What I'll suggest you to do alternatively is that here, just look at this graph. Which graph, sir? I will draw it separately for you. I hope everybody is paying attention here. I will draw it separately for you so that no confusion stays there. Let's say this is the y-axis over here, and this here is the x-axis over here. So I repeat one thing. Do you remember that cosec inverse x is what we are willing to draw? We are willing to draw the graph of cosec inverse x. Sir, first of all, you help us with the values of x. You tell me, for sine inverse x, this x was between minus 1 to 1. So technically it is the reciprocal now. So all the values which are between minus 1 to 1, their reciprocals will be either less than minus 1 or greater than 1. Can you process this idea? Reciprocal, reciprocal. So there I'm telling you that here, first of all, x will be either less than minus 1 or greater than 1. Everybody got this idea? Yes or no? Yes or no? Comfortably. So here I'm suggesting a simple fact that cosec inverse x, when you wish to draw as a graph, it will take the inputs from minus infinity to minus 1 or 1 to infinity. This is what is going to exist along with the x-axis. Let's talk about the y-axis. So y-axis is also very much sorted. I hope you remember. For sin x, what did we discuss? For sin inverse x, we said sin inverse x produces the range closed interval minus pi by 2 to pi by 2. The same output will be produced by cosec inverse x as well. But the only problem here is that 0 wouldn't be there in its range. The simplest idea which I'll try to suggest you is sine 0 is 0, cosec 0 is not defined. So cosec inverse of not defined will be 0 if you are able to process my statement mathematically. Getting my point, everyone? So what will I say here is that, sir, somewhere here you will see a point minus pi by 2. Somewhere here you will see a point pi by 2. At pi by 2 you will see it 1. At minus pi by 2 you will see it minus 1. And then between, I hope you're understanding, minus 1 and minus infinity, it will take all the values from minus pi by 2 to 0. And between 1 and infinity, it will take all the values from 0 to pi by 2. And this is nothing but beautifully drawn the graph of cosec inverse x. Were you all able to digest it? Were you all able to get it? Are you all able to conclude a lot of things here based on this curve? That said, domain here is clearly either minus infinity to minus 1 or 1 to infinity. And range here is minus pi by 2 to pi by 2 excluding 0. Does it make complete sense? Are you all able to process this idea of cosec inverse x? And that's exactly what I'm trying to highlight here in terms of the domain and range here. Look at this cosec inverse x. The inputs which it is taking are either less than minus 1 or greater than 1. But in terms of outputs, as I have been clearly and constantly mentioning here, I hope you do remember that sine inverse, tan inverse, and cosec inverse stay on the same side in terms of range. Minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, minus pi by 2 to pi by 2. The only challenge is tan inverse x uses open, sine inverse x uses closed, and you know the logical reason and explanation behind that. And cosec inverse excludes 0. Sir, why? Because cosec 0 is not defined. So cosec inverse will not be able to produce the output 0. Input, output, range, domain, domain, range, function, inverse of a function. If you remember all those discussions we had in the chapter relations and functions, specifically regarding inverse function, all of those ideas only I'm applying here in this case. Able to get this? Now the final part. Shall we talk about sec inverse now? Shall we? Everybody paying attention? So if I could quickly show you how do we draw sec inverse, this is even more beautiful. The way we drew cos inverse x, the way we drew cot inverse x, in the same fashion, I will restrict sec inverse x as well. Here, I repeat, I will first of all help you with the graph of sec x. So this one, the white one. The white one is the graph of sec x between 0 to pi. Although it's a periodic function, but I'm restricting it between 0 to pi. I hope it is not looking very confusing. You are able to make some sense out of it. I repeat, between 0 to pi, if I restrict the domain of sec x, so x is an angle which is taking values from 0 to pi. Of course, pi by 2 is going to be the point where sec x will be not defined, because cos x at pi by 2 becomes 0. So sec x will be not defined. Here I'm trying to say that cos was taking values from minus, I hope you remember, minus 1 to 1. This is how we were drawing the graph of cos x. Remember that? This is how we were drawing the graph of cos x. Remember that? This graph is demonstrating the graph of y is equals to cos x, for better clarification. So all I have technically done is nothing, but what I've done here is a very beautiful thing, that here I have just taken, this bucket was upside down, so I've just inverted this bucket. This bowl or bucket was like this, so I just inverted this bucket because they are technically reciprocal of each other. So with this idea, if I could proceed further from this point here, I hope you can completely make sense out of this, that cos pi by 2 is 0. So sec pi by 2 will be not defined. So this line, x is equal to pi by 2, will behave as an asymptote here. That means this line will not be touched by these curves at all, or either at infinity. Now, what's my point here? My point is really simple. Again, that single logic if I apply, that if I take reflection of this white curve with respect to the line y is equals to x, will I not be in a position to draw the graph of sec inverse x? Inverse functions exist in that manner only. So if I could use that idea, I hope you are realizing the image of this in this line will be this, the image of this will be this. That idea you could have followed. But sir, we don't believe in this. It's very confusing. Can we do something else? Yes. What is that something else? Let's do it for the one more time, and then we'll be done with all the graphs, and you would have developed a complete, crystal clear, total understanding on all the functions of this ITF chapter. So this is your y-axis. This here is your x-axis. Now pay complete attention, everyone. Here, if I could relate the whole thing here, what are we noticing here? Sir, few things which you all must have noticed is that we restricted sec x between 0 and pi. So if the 0 to pi was the domain for sec x to define its inverse, in its inverse, 0 to pi will be the range. Getting it or not? So 0 to pi here will be the range. So there will be a point 0, there will be a point pi by 2, and there will be a point pi. But again, if I repeat that same logic, cos x stays between closed -1 to 1. So sec x, its reciprocal, will be either less than -1 or greater than 1. Able to imagine it in your brain? Reciprocal functions they are. Reciprocal. Sec is reciprocal of cos. So cos produces the output from -1 to 1. Sec will produce the output either less than -1 or greater than 1. So based on that, will I not say that sir, sec x when I look at, it will take values from -infinity to -1 or from 1 to infinity. As we can clearly see the graph existing between -infinity to -1 or 1 to infinity, the white graph I hope you are looking at. With that thing in mind, if I could talk about the domain here, sec inverse x if I'm talking about domain. So sec x had the range from -infinity to -1 or from 1 to infinity. So this range of sec x will become the domain of sec inverse x. So here domain will be -infinity. Domain will be -infinity to -1 or 1 to infinity. Everybody able to process this whole thing without any hesitation? Are you all there listening, watching, and understanding comfortably with complete crystal clear clarity? How are we drawing these curves? With this, if I try and bring the final thing in picture, you tell me a few things. Will I see the existence of the graph around this point pi by 2? Of course not. Sir, why? The whole reason is pretty simple, because cos pi by 2 is 0, sec pi by 2 is not defined. I will not see the existence of the graph here. So what I'll notice here is that y is equal to pi by 2 will be a line parallel to the x-axis, where I'll see it treating or behaving as an asymptote to the curve. So with this, if I could finally draw the curve, I hope you are clearly noticing that, sir, either this version or this version I'll take. What do I mean by that? I hope you are clearly noticing that here -1 I'll get at pi, or vice versa I'll say. At -1, sec inverse of -1 will give me pi. Sec inverse of 1 will give me 0. So this is how I'll produce. But if I take all the values between -infinity and -1, it will go like this. Yes or no? And if I go ahead with all the values from 1 to infinity for sec inverse x, this will take all the values between 0 to pi by 2. But of course, no matter what, it is not going to take any value between at pi by 2. With the practice, with a lot of questions, you can learn a lot of formulae. There is no guru mantra. I repeat, what did we notice here? If you look at the graph of y is equals to sec inverse x. Thank you so much for your beautiful compliment, Subaru Natsuki. Thank you so much. But I hope it makes complete sense that when you notice this part beautifully, the domain of sec inverse x, when you look at, it is from -infinity to -1 or 1 to infinity. existence of the graph. But sir, when you talk about the range, the output which sec inverse x produces, so that range is from 0 to pi excluding pi by 2. Now with this conclusion in mind, if I now go back to this table, does it make complete sense? Does this table make sense? I would first of all urge and request everyone to take a screenshot of it. Take a screenshot of it. Because when you take the screenshot of it, this is going to matter the most in this chapter. When we study the chapter Inverse Trigonometric Function, this is, I'll be reminding you time and again. Every time, I'll just ask you to go through this slide. I'll just, in any question if I'm doing, I'll say go back to sine inverse x or cos inverse x. What was the domain? You will say -1 to 1. So notice few patterns which I'm trying to highlight here. For sine inverse x and cos inverse x, the domain behaves same. For tan inverse x and cot inverse x, the domain behaves same. And you know the reason now. You have understood the graphs pretty well. When you look at sec inverse x and cosec inverse x, you see the domain to be same. So either less than -1 or greater than 1. You would be able to process it more comfortably now because you have understood trigonometric functions more comfortably now. You know the pattern now. Having said this, I tried telling you few more facts that sine, tan, and cosec will stay on the same page. Sine produced an output minus pi by 2 to pi by 2, noticing it. Tan also produced, tan means tan inverse I'm saying, produced an output minus pi by 2 to pi by 2 with open. Cosec also produces an output minus pi by 2 to pi by 2 closed, excluding 0. And you know the reason why. We have gone through it now in a more comfortable manner. Similarly, the last fact which I'll say is that at a lot many times you will see similarity between cos inverse, cot inverse, and sec inverse. Beginning with this part that cos inverse x produces the output from 0 to pi, closed. Cot inverse will also produce the output 0 to pi, open. Sec inverse x will also produce the output 0 to pi, excluding minus pi by 2. Does it make some sense? Are you able to process it, or is there still any confusion? I repeat, I said sine inverse x and cos inverse x in terms of domain stay on the same side. Tan inverse x and cot inverse x in terms of domain stay on the same side. Sec inverse x and cosec inverse x in terms of domain stay on the same side. But when I classify these three things, which three things? Sine, tan, and cosec, then sine, tan, and cosec stay on one side. And the remaining three, which three students? Cos, cot, and sec stay on the same side. So I hope you will remember these patterns, these ideas. Sir, why are you still emphasizing so much on this? I hope you have taken the screenshot. Please remember this table. Keep it stored somewhere, because keep it pasted in front of your study table. Go through it every day. Trust me. If you have this data, these figures in your mind, you will be able to deal with questions on ITF in a more better manner, in a more confident manner, in a more proper manner. Trust me, mark my words. I'm not just saying this unnecessarily. I'm putting my complete attention on this part here because I want you all to understand that the better clarity you have on these things, the better you'll be able to solve or deal with the questions. I'll show you in the upcoming slides. All the properties we'll be studying in the upcoming slides will very highly dependent on these values. So I'm constantly trying to tell you certain patterns. I'm sure by now you must have understood that domain wise it is same. Range wise sine, tan, cosec, and cos, cot, sec are same. Will you all remember that? Good to have you, the crazy gamer. Shall I move ahead from here? If you have processed all the inputs, whatever I've said so far, without any confusion or hesitation. By the way, this entire PDF which I'm creating right now will be totally yours. After the session, we'll be uploading it on our WhatsApp channel. And the link to our WhatsApp channel is given in the description. You can check it out. Yeah, coming back to this. What are we discussing here now? Furthermore, few more graphs, few more curves. Let's say if I ask you to draw the curve sine of sine inverse x. Now pay attention everyone. How do we deal with sine of sine inverse x? Can you help me in defining its domain and range? Let's work it out. Please pay attention everyone. Forget this thing written over here. I'll ask you to deal with it separately. Let's say I'm asked to deal with sine inverse of x. You begin with this internal function. If I try to look at its domain, I'll use the inside out approach. So what does inside out approach says? Sir, the inside out approach says that this x. Now go back to that table. What did we discuss in that table? Sir, we did discuss that in table sine inverse x allows x only at those points where x is between -1 to 1. So this here, x as an input is passed to sine inverse. That eventually is an output passed to sine, which is perfectly fine. But you tell me, this x is what? Angle or value? So it is value. It is passed to sine inverse. So if it is a value passed to sine inverse, I know for sure that x is going to take values from -1 to 1. So that I know for sure that ultimately in the end, when I'm going to draw the graph of y is equals to sine of sine inverse x will absolutely, clearly, and totally lie between -1 and 1 only. But how would the graph look like, that I don't know yet. But I know this thing for sure, that this is what is going to happen. Can you believe this? JEE Mains has asked a question once where it has asked the value of sine inverse of 1.5, and a lot of students believed that sine and sine inverse are inverse of each other, they nullify their effect, and they wrote the answer as 1.5. Can you believe this? They did it. And I'm sure some of you must have realized by now that it is completely impossible, because here also I'll say it does not exist. Why? Because go back to that table which will tell you that, sir, if you want sine inverse to be defined, inputs should be from -1 to 1 only, and you're passing an input 1.5, and you're coming up with the logic that sine and sine inverse are inverse of each other, then nullify, and ultimately you'll be left with 1.5 as the answer. Is it not totally wrong? Absolutely wrong. Terribly wrong. It's a bad practice. So I hope you realized it's clearly a mistake here. Everybody getting it? So first of all, you don't say that sine of sine inverse x is x. You need to ensure that it is x if x is between -1 to 1. Now imagine this. You passed an input 1 by 2. So it tells you that sine inverse 1 by 2 is 30 degree. So this produces an output which is going to be what? An angle. So sine of that angle produces an output. Sir, sine of an angle, that angle is taking all the values from -π/2 to π/2, yes or no? If x is from -1 to 1, can you help me with sine inverse x? Sir, sine inverse x will take all the values from -π/2 to π/2. So if I process all the values from -π/2 to π/2 to sine, what will it say? It will say, I will produce all the values from -1 to 1. So I'm sure now that output also, the graph of this function will say output also is going to stay between -1 to 1. So for this function, one thing I know, that domain and range both are -1 to 1 closed interval. Which means up to an extent, it's totally a good or a great idea that sine and sine inverse will nullify each other and I'll be left with x. But not always. It will happen only when x is from -1 to 1, and that's a fact which a lot of students miss. That's a fact which a lot of students miss. Bharat, if you're saying sine inverse is also cos inverse, then you're making a mistake. Let me tell you the mistake. Please understand, Bharat. As I have told you in the beginning only, you may have missed it. There is a difference between sine inverse x and sine x to the power -1. This is not power -1. This is an expression, a symbol, denoting that it is an inverse function. So this means that it is inverse of sine x. But here, if I define something as sine x to the power -1, so this means 1 upon sine x, and that's what you call as cosec x. So it is totally different. This and this are not same. Please understand this mathematically. Got my point? Shall I get back to the discussion we were having? Here we are. So I said, yes, sine and sine inverse will nullify the impact of each other, and you will be left with x only in the end. but you need to ensure that that x is from -1 to 1. So yes, y is equals to sine of sine inverse x can be written as y is equals to x, but you need to restrict x from -1 to 1. So an identity function you are willing to draw between -1 to 1, I hope I did not tell you how do we draw the line y is equals to x, but the domain is -1 to 1. So this is still that same line y is equals to x. This is still that same line y is equals to x passing through origin, of course, but here x gets restricted between -1 to 1, and you know the reason now why. Because ultimately it is passed as an input to sine inverse. Yes or no? Is there any confusion, or shall I re-explain this part? Everybody got it comfortably. In the same fashion, in the same manner, will I not define cos of cos inverse as well? Cos of cos inverse as well will be defined in the same manner, yes or no? Let's say if I ask you, there is a function y is equals to cos of cos inverse x. Now the idea remains same that, sir, x is passed as an input to cos inverse. So what will cos inverse allow? Cos inverse will allow x to stay between -1 to 1. That's the domain here. Now the next thing, cos inverse x will produce the outputs from 0 to pi, but it's not the range. 0 to pi, the output produced by cos inverse x is passed as an input to cos. Composition of functions, remember that? So if cos takes inputs from 0 to pi, cos taking inputs from 0 to pi will produce the outputs from -1 to 1. So this is going to be the range. I mean, if these all were the values of x, these all are the values of y. So this will also behave clearly as an identity function, which means this will also have the graph drawn like exactly this. Exactly this. This point will be -1, this point will be 1, this will be 1, this will be -1. So yes, this again is the graph of y is equals to cos of cos inverse x. But do you all realize that here also, this is defined as long as x is between -1 to 1. Now I'll show you a graph and ask you that can you explain this one? Can you explain this one? Tan of tan inverse x or cot of cot inverse x. Anybody? Everybody got this? Can you crack this? Tan of tan inverse x and cot of cot inverse x is same. I think Bharat, you were saying sine inverse of sine x and cos inverse of cos x are same. I think I misinterpreted your statement. Anyways, I hope the same thing. I hope you got it now, everybody. The same logic we can apply on tan of tan inverse x and cot of cot inverse x. Can I explain it for one? Other one, will you explain or digest by yourself? For tan, if I do the same thing, tan of tan inverse x. So this x will say that I can take any real value. Remember the domain of tan inverse x, we said tan inverse x in terms of domain can take any value from -infinity to infinity. Imagine that graph. Are you able to imagine that graph? With this, if any real value is passed due to tan inverse will produce an output. Tan inverse will produce an output from -pi/2 to pi/2. Remember that thing, everyone, yes or no? Now the next thing. If tan inverse x is producing angles from -pi/2 to pi/2, so all the angles from -pi/2 to pi/2 are passed to tan. So what will tan say? Tan will say, I will again take all the values from -infinity to infinity, yes or no? Because graph of tan x between -pi/2 to pi/2 stays from -infinity to infinity. Okay, Bharat, sincerest apologies. I misinterpreted, but you should have written it more properly. I think you were also saying the same thing which some students were saying. Anyways, you could have corrected me otherwise if I was taking it or interpreting it like that. Coming back to the discussion. So I hope this part makes complete sense, whatever I'm saying here. So here, the most beautiful thing happening over here is that yes, for tan of tan inverse x, you can believe or assume it like that this tan and this tan inverse can nullify each other's impact and it will give me x. And that x will be x for any real value of x. Because for sine of sine inverse or cos of cos inverse, this x could be between -1 to 1. So I had to restrict the graph between -1 and 1. But here there is no challenge. There is no challenge. If I draw y is equals to tan inverse of x. So it clearly tells you that it is defined for all the real values of x, because tan inverse can take any real number as an input. So if it does, I hope you do accept that tan and tan inverse will be nullified. And what will I be left with? I'll be left with y is equals to x. So it is equivalent to y is equals to x, where x can be any real number. Shall I repeat that? Everybody got my point. So a straight line. The same graph will be drawn for cot inverse x. That too for all x being real numbers. Any confusion so far? Did you all get it? Everybody processed it. Everybody digested it. Now, can you help me with this statement here? Can you help me with this statement over here? Anyone? Vijay, पानी देना ना भाई बॉटल. ठीक ठीक. Normal चलेगा. Okay. Coming back to this discussion, everyone. Now, as I have been clearly mentioning in terms of inputs, sine inverse and cos inverse x stay on the same page. Tan inverse x, cot inverse x stay on the same page. Sec inverse and cosec inverse stay on the same page. Remember that discussion, yes or no? So what will I say in this case? I will say that if I'm talking about sec of sec inverse x or cosec of cosec inverse x, then this x as an input, this x as an input will say that keep me either less than -1 or greater than 1. Remember that? Remember that? Remember that? Yes or no? I hope you do remember. So if I do ensure that to these functions, sec of sec inverse x or cosec of cosec inverse x, if I pass an input either less than -1 or greater than 1, then the output will be x. So someday, if somebody asks you in a question, what is the answer of sec inverse of 0.5? What will you say? What will be your answer in that case? What is going to be your response in that case, students? Will you all again not say that, sir, you're creating a problem? 0.5 is something which is 1 by 2, which is lying between -1 and 1, and that's not an acceptable input for sec inverse or cosec inverse. So this will not be processed. Sec inverse cannot digest it. It cannot accept it. It cannot process it. So if this cannot be processed, there will be no output. And if there is no output which can be treated as an input for sex, I think you got it wrong. It is clearly not defined. It does not exist. I hope it is not defined. Not defined does not mean -infinity or infinity. Here it means I just cannot find it. There is a problem here. Did you all get my point, everybody? Now with this, I think it's the high time that we solve some questions. So I'm showing you some questions. You try them. Let me have some water and then we'll solve them together. As soon as you get the answer, do write your answers in the comments. I'll really appreciate if you do them genuinely by yourself and write your answers. So keep your pen and paper there with you and keep solving these questions based on whatever we have learned and understood so far. Try these questions, everyone. In the same fashion, Thanos is also a very underrated character. I believe that he should be. I think whatever he said, he did could be wrong, but whatever he suggested or said was up to an extent was right. Yes or no? Coming back to this. Find the principal value of the following. Shall we try the first question? Let's begin with the first question. The live got started at 8 o'clock. So if you missed it, you can rewatch it once the session gets over. But right now, focus on what we are solving or doing. Shall I get this question done and will you crack the other parts by yourself? Let's do it. If you feel confident, we'll not do these. If you don't feel, we'll do them further. First of all, Cosec inverse 2 I wish to deal with. Okay, sir. So the best practice is cosec inverse of 2. Technically, it's an angle. It's an output. Beautiful, excellent. So if it's an angle, I call it alpha for a while. So if cosec inverse 2 is alpha, you should not hesitate in saying that cosec alpha will be 2. There should be an angle, numerically smallest value. So I'm simply looking for the numerically smallest possible value for which cosec ratio when it's taken is 2. If you don't know it, you can take the reciprocal. Cosec alpha, you can treat as 1 upon sine alpha. 2, you can treat as 1 by 2. So I hope this also makes complete sense. Now I think you are in a better position to tell me numerically smallest possible angle, which gives you 1 by 2 when sine ratio of that angle is taken. Will you not say that, sir, it is clearly 30 degree? So will I not say alpha is clearly pi by 6? Absolutely straightforward, clear. So will you try these questions by yourself and get these answers? Shall I get those done? I hope I need not. Let me get one more question done. Third question I'll give you as a homework so that when you receive this PDF, you try those questions by yourself at home. So second question I'm getting done here, but third question I'm giving you as an homework. Sir, how do we receive this PDF after the session? After the session, we'll be uploading this PDF on our WhatsApp channel. Sir, how do we follow your WhatsApp channel? The link to our WhatsApp channel is given in the description. Good. Excellent, Bharat, Sanjana, and everyone. Keep it up. Very good. The second question, tan inverse minus root 3. Again, tan inverse of under root over minus 3, under root negative of root over 3 is clearly an angle. So I can say that tan beta will be negative root 3. Yes or no? Sir, how do we process it? If you're not able to, just take this minus sign here. I can write it as minus tan beta is equals to root 3. Now, tan as a function we know is odd. We have seen it in relations and functions. So, tan beta or minus tan beta, can I write as minus tan beta? I mean tan minus beta, which I can write as root 3. Now, you just help me with this angle root 3. I mean, for what value or for what angle do I get a ratio of that angle? Tan ratio of that angle is root 3. I think, sir, 60 degree. So I'm trying to say that minus b here is 60 degree. What is 60 degree? Pi by 3. So with this, we conclude it like this. Although you don't have to do it, do this in boards. But in IDJ, I think you are intelligent enough to claim that this minus root 3 for tan inverse is going to be minus pi by 3. You're intelligent enough to conclude or process all of this in your brain. You don't have to write all this. So this third question I'm assigning you as a homework question, hoping and believing you would try it by yourself at home. Shall we try something better? Can you tell me the answer of this question without cheating, without using AI, by your sincere and genuine efforts in the comments? What is going to be the answer to this? Of course, an expression it would be. So what would that be? I mean, I'm looking for x. If sine inverse x is set to be greater than minus 1, what about x? What can you conclude on x? What can you generate on x? What can you say about x? That's my question. I'll say if you don't get anything, go back to the graphs. Go back to the graphs. If you go back to the graphs, you will notice that, sir, this is how we draw the graph of sine inverse x. This is how we draw the graph of sine inverse x. This is how we draw the graph of sine inverse x. Do you remember that? I think we started our discussion with this thing only. So this is the graph of y is equals to sine inverse x. Now, trust me, you can do it within seconds if you remember the graph. How? I am told sine inverse x is greater than minus 1. The best thing in life is that sine inverse as a function is strictly increasing. Sine inverse x is clearly a strictly increasing function. Yes or no? It is indeed. Sir, what is minus pi by 2? I hope you do accept that minus pi by 2 is approximately minus 1.57, half of 3.14. Pi by 2 is clearly approximately 1.57. I think that we don't need, but what we need is sine inverse x. I want it to be greater than minus 1. Yes, there is a separate batch of English in PW. We call it PWJE in English. That's a channel. And there exists a batch Arjuna and Laksh, like that, the way you see in English, or for some other languages. We do exist. Thank you so much for recognizing and acknowledging us. So I say if it is minus 1.7, above it, I'll see minus 1 somewhere here. Do you all agree? So, sir, we are technically looking for the values. We are technically looking for the values which are greater than minus 1. I hope. What are they saying? They are wanting that sine inverse x should stay greater than -1. So if I could show it to you in a more better manner, this point to these points are my acceptable zone or points on the graph. But sir, that's all about sine inverse x. You are still not concluding anything on x. Have patience. I am saying that if you still pay more attention on this part, sine inverse x, what did I say? Strictly increasing function. So if I relate it here, this will be a point. Sir, you don't know about anything about this point. Okay, have patience, we'll conclude it. And this finally is this output here. So if it was a strictly increasing function, if I could rewrite it in a better manner, will I not say that sir, sine inverse x, they want it to be greater than -1, but the maximum value of sine inverse x is pi by 2. And the most beautiful thing which is happening over here is you can do it in one line, but I'm demonstrating it with the graph so that you can process it in a more clearer manner. There I'll say that if I take sine ratio on all the three sides, so why? Because sine is a clearly strictly increasing function here. I can take the sine ratio. So I'll say sine of -1 will be less than sine of sine inverse x, which leaves me with x because I'm fulfilling that criteria. And here, this is sine pi by 2, which I am writing here. Sine is an odd function. So sine of -1, Arjuna or Arguna Sahityan, by the way, welcome back. You may not be able to understand all what I'm doing here, but still welcome. Sine of -1, sine being odd function, will produce an output sine 1. This is going to be the value of x. And this here, sine pi by 2 is clearly 1. That's exactly what we did here. Can you help me with this point here? -1. How do we produce -1? So technically, this -1 getting produced because of this point. So what is this point? I hope you are clearly understanding. -1 is the output. Output of which point? Output of this point. So if I are still not able to get it, let me call this point some value. What value? Let's say any value. Let's call it k. So will I not say that sine inverse of k will be -1? So I hope you're understanding. My point is sine of -1 will be k. So that's my point. Sine of -1. Are you all able to process it? Technically, I have given you two approaches. One was graphical approach. One was observation-based approach. I think this looked shorter, but to apply this, you need this understanding. Yes, input, output. Good, 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 Dhairi. Beautiful. Everybody understood the whole solution. Any queries, any confusions, any concerns regarding anything, please ask. I'll clarify. Shall I move ahead from here, all the participants? Are we good to go? Shall I give you the next question here? Again, there are three questions. I'll get any two done. Then third one, any one, which is the remaining one, will give you as a homework. Again, as I have been clearly mentioning, you can avail this entire PDF of this entire chapter, Inverse Trigonometric Functions, on our WhatsApp channel. The link to our WhatsApp channel is in the description. And one more very beautiful thing I wanted to highlight to you all is that on our PWJ English channel, we are bringing something amazing. That is tomorrow. So tomorrow something amazing is going to happen. This thing, tomorrow, 16th of July. What is GOAT? Or who is GOAT? Something really exciting is going to happen. So don't miss this part. Okay. It's like a commercial is going on in between. So YouTube already offers us commercials, sir. You're also giving us commercials. Come on. So I'll solve this question. First of all, let's begin with this first one. Shall we, everyone? Shall we try the first question here? So what does the first question say? So if you try and solve the first question, it says, let's read the question first. Find the value of x for which the following expressions are defined. So sir, it looks like a question from the chapter Relations and Functions. I think it's like a domain-based question, isn't it? So if I wish to define this sine inverse of 3x minus 2, sir, I know whatever input you pass to sine inverse, that input has to lie between -1 to 1. Good there. I hope you got my point. My point is sine inverse says that I take inputs from -1 to 1 only. So here in this case, input is 3x minus 2. So It is my responsibility or job to ensure that 3x minus 2 stays between -1 to 1. Getting my point, everyone? So with this idea, if I add 2 on all the three sides, -1 plus 2 is 1. This is 3x and 1 plus 2 is 3. If I divide both the sides, all the three sides by 3, it will be 1 by 3. This will be x and this will be 1. So here this 1 by 3 to 1 is nothing, but here the domain of this function will say that x has to lie between 1 by 3 to 1. I hope it was easy, comfortable, direct, straightforward. Everybody was able to crack it or think of it. With this logic or idea, can you help me in cracking the second question? And if you do so, will you write your answer in the comments? I'll really appreciate it. Shall we try the second question here? Let's solve the next question. Cos inverse of log x at base e. So here, what does it say? So let's try it. Cos inverse also says that whatever input you pass me, that input has to lie between -1 to 1. So sir, you're saying that this log x at base e will lie between -1 to 1. Yes, I'm saying that. Although you know the nature of the function log x, here, this is how you draw the graph of log x. It is again a strictly increasing function. E shouldn't be equal to 1. E is the Napier's constant there. So E is 2.73 and so on, an irrational number. So it's E. So I hope this part is very well understood by everyone. Yes or no? This is cos inverse, has an input log x. And log x, we know, is an input of cos inverse. So I need to ensure that log x stays between -1 and 1 because it is passed as an input to cos inverse. So sir, I wish to take anti-log here. Anti-log I can take e raised to the power -1, e raised to the power 1 without even change in sign, because e as a base, I know, is approximately 2.7, which is greater than 1. So if the base is greater than 1, I will say I need not change the sign. So if I take anti-log e to the power -1 less than equal to x less than equal to e to the power 1. Do you know this concept of taking anti-log? Yes or no? So here I'll say that x lies between 1 by e to e, which means for this function, the domain is going to be 1 by e to e. Did you all get it? Did you all understand it? Or shall I re-explain any part of this question? Everybody could understand it. Everybody could get it. Everybody was able to process it. The whole thing which I did here. Any queries or confusion so far regarding anything we have done? Shall I move towards the next question, the third one? Third one, if I try, what do I get with this? Let's solve the third one, the next one. Again, a very beautiful one and a more insightful one. Shall I give you the third one as a homework question? But before I give you the third one as a homework question, how many of you cracked this second question or were able to? There is saying for our log function to satisfy base should not be 1. Yes, the base is e. E is Napier's constant. That is a fixed number. That's an arbitrary constant. 2.7321 and so on. So it is not at all 1. You're thinking correct, but e is a fixed number. Coming back to this. Now the third question I'm assigning you as a homework question. I'll just give you the hint. Sec inverse. Remember that sec inverse takes the inputs which are either less than -1 or greater than 1. So I hope you know what to do. Have you not solved inequalities based questions? So what you'll do is you will solve this one separately. You'll solve this one separately. You'll get an answer from here. You'll get an answer from here. And then ultimately in the end, you'll take the union because OR gives you the union. So this third question I'm giving you as a homework question. This entire PDF will be totally yours. After the session, we'll be uploading it on our WhatsApp channel. The link to our WhatsApp channel is given in the description. Shall we try the next question with this idea? Shall we, everyone? Let's give it a try. What does it say here? It says that cos inverse lambda, cos inverse mu, cos inverse gamma is 3 pi. Then they are asking you to find the value of lambda mu plus mu gamma plus gamma lambda. Okay. Sir, forget this whole thing. If I just ask you to tell me cos inverse x, what does it produce as an output? So sir, cos inverse x always lies between 0 to pi. Remember that thing, everyone, we did discuss that no matter what, cos inverse x always stays between 0 to pi. Give me a second, everyone. Let me just, yes, we are going great. I repeat, what did I just say so far? That cos inverse x as a function produces the output from 0 to pi. Yes, absolutely right, absolutely correct. Then imagine this cos inverse of something. So I hope you are able to get this whole thing that cos inverse x is always greater than equal to 0. I mean, what I'm saying is that cos inverse x is always non-negative. What is non-negative, students? Are you understanding the meaning of the word non-negative? Non-negative means either 0 or positive. Now try and process this statement here and apply this logic here when you're told that 3 non-negative values you add and you get 3 pi. Apply your brain, apply your intelligence. Can somebody write the hint which I'm trying to suggest or come up with this here in this question? Can somebody tell me what am I asking you to think here? Imagine this. I am adding 3 non-negative numbers. Non-negative means either 0 or positive, and their sum is turning out to be 3 pi. Where I know one thing for sure is that cos inverse stays between 0 and pi only. Can somebody tell me what am I asking you to think or do in this question here? In the comments. Anybody? Are you realizing that, sir, the only way you could ensure that this sum becomes 3 pi only when cos inverse lambda becomes pi, cos inverse mu becomes pi, and cos inverse gamma becomes pi. That's the only way of getting 3 pi. Otherwise, you cannot. Sir, how can you say it like this? How can you just think like this? I'll say we can, because I hope everybody is realizing, everybody must be noticing that, let's say I don't take it as pi. So can I take a greater value than pi? Of course not. Cos inverse does not produce a value greater than pi. So what if I give it a value less than pi? So if I give it a value less than pi, to compensate for it, to adjust it, I need a greater than pi, a value greater than pi. But this also being cos inverse cannot get or produce a value greater than pi. So they have this constraint, they'll stay between 0 to pi. If I give them a value less than pi, others will have to compensate for it. And the whole problem is pretty simple here, sir, that if you reduce someone, you got to increase someone. And they cannot be increased further because their hands are bounded. They'll stay till pi only. So if I want the sum to be 3 pi, the only possibility I have is all the 3 cos inverse gamma, cos inverse lambda, cos inverse mu have to be pi each. Getting my point, everyone? So what did we conclude? That cos inverse gamma, cos inverse mu, cos inverse lambda all are pi. So if cos inverse lambda is pi, I hope I need not tell you, lambda will be cos pi and cos pi is -1. Similarly, will you not say mu and what do we have? Gamma will also be pi. So lambda, mu, gamma, all these values will be cos pi, which is -1. I think we are done. Good, Dhairya. I think we are totally done with this question because this is -1 into -1, which is 1. This is -1 into -1, which is 1. This is -1 into -1, which is 1. The answer would be 3. How many of you were able to crack this question? How many of you were able to apply this logic over here in this question? Everybody was able to think like this? Yes or no? Any concerns or queries or confusion so far? Tell me if there are any. Shall I move ahead with the next question? Everybody comfortably processed it without any hesitation, concerns, or queries. Shall we try the next question with this idea, with this philosophy? Yeah. It says that, sir, in this question, we are told that cos of 2 times sine inverse x is 1 by 9. Then please find the values of x. Okay. Let's try it. How do we work out these kind of questions? So to deal with these kind of questions, the best practice will be do something with this sine inverse. So what do you mean by that? Let's say for a while, if I take sine inverse x as theta, Because sine inverse x is what? X is a value. Whose sine inverse when you take, it will produce an angle. So can I take it as theta? So I hope nobody is confused if I call sine theta to be x. Because if sine inverse x is theta, sine of that theta will be x. It's a fact. I hope I can do that. Now, here in this part, if I wish to solve it, this is cos, this is 2, and sine inverse x I have assumed as theta, which is given as 1 by 9. Now, sir, cos 2 theta has 3 varieties, rather 4, but even if I could introduce 3, one of them is, I hope you have studied cos square theta minus sine square theta. Other one is 1 minus 2 sine square theta, and third one is 2 cos square theta minus 1. Remember that? One more is there in 10. Can you write that one in the comments? I'll really appreciate it. MN Vishit, I think you won't be able to process it. Right now at this stage, it would be a little difficult. But still you can try. If you are able to process it, we'll be really happy. If you're not able to, you can leave. That's totally your choice. Yeah. I think I need to deal with cos 2 theta, and preferably I'll use this version because I know something in sine. Understanding my approach, getting the idea that why am I doing this, able to process this whole thing. So if I could think of this, if I could apply this cos 2 theta, what is cos 2 theta? Sir, cos 2 theta can be written as 1 minus 2 sine square theta, which I can treat as 1 by 9. So if I take it here, so 1 minus 1 by 9, I think is 8 by 9. Can I do that calculation in a little quicker manner? And that's 2 times sine square theta. So can you help me with sine square theta? So sine square theta will be 4 by 9. Everybody getting it? Everybody getting it? Yes or no? So if sine square theta is 4 by 9, I hope I need not tell you, sine theta will be plus minus under root over 4 by 9. That's 2 by 3. Now you help me with one thing. I am getting two values of sine theta. I am getting two values of sine theta, which are minus 2 by 3 and 2 by 3. Are they acceptable values here? Sir, why are you saying acceptable values? Because you should think that, sir, do they lie between minus 1 and 1? Yes, little stars, they do. Good, excellent. I hope you realize 2 by 3 is 0.66, less than 1. Minus 2.3 is minus 0.66. What is this mosquito doing in our class? Okay, let me catch the mosquito first. We have caught it, we have killed him. No, it's not killed. Anyways, forget him. Because he will bite me and he will bite me bad. Okay, so I cannot catch him. You are enjoying watching it live? Your teacher of maths catching the mosquito. Okay, so we are going back. I was telling this is minus 0.66. This is greater than minus 1. So both of these values lie between minus 1 and 1. So if they both lie between minus 1 and 1, sine theta stays between minus 1 and 1. So they both are acceptable outputs. Sir, what was sine theta originally? Sine theta originally was x. So I think I have cracked x, which is taking two values, minus 2 by 3 and 2 by 3. And that's my answer. So we found the values of x, didn't we? Was it not simple, easy, direct, straightforward? Yes or no? Decent? Everybody understood it? Any queries or confusions? Shall I move ahead from here, all the participants? Let's do one more question. Or shall I give you this question as a homework question? Or shall I give you a hint here in this question? What do we do? Three choices. Either I get it done totally, or I give it completely to you to be done by you, which you can avail this entire PDF of this entire session after this session through our WhatsApp channel. Link is there in the description. Or the third thing, I solve it half, give you the hint, and then you try it by yourself at home. MN Vishit, this is not a tuition. We have an agenda. Inverse trigonometric functions is going on and we are completing it. So your query will be addressed, but not today, some other day, when I'm handling all the concerns like that. Coming back to the discussion. I repeat, this is what we need to solve. So I'll again follow the same idea which we did in the last question. Can we do that? We'll do it very soon, don't worry. So here we are. I'll say this part here. If I just simplify this part. So I'm going to give you this question as a homework question. I'll solve it half, which means I'll give you the hint, and I'll be hoping and expecting that you try this question at home. Will you? I think we have done sufficient questions. Now, I should not spoon feed you. You should also be able to think. So if you want to develop that thinking, that process, that how do we solve, you need to solve. By looking at solving someone, you may not be able to understand the process, or you may be able to understand the process, but you may not be able to apply that process. So if you really want to learn the application, you try that by yourself. There you'll fail and struggle and then come up with the solution. I think Little Stars has already given us the answer. That's beautiful. And I'm sure you're not using AI. These are your genuine and sincere efforts. So here my suggestion is cos inverse minus 3 by 4. You just treat as one of the angles alpha. So you will say cos alpha as minus 3 by 4. Now I hope it makes complete sense. Will you solve it by yourself now? Can you do it by yourself now? What are we doing here? Cos inverse minus 3 by 4, if I am treating as alpha, I am now trying to work upon sine alpha by 2. Sir, sine alpha by 2, we want to figure out. And we know cos alpha. How? Can you just give us one more hint? Trust me, if I could give you one more hint, the question will be solved. So my hint or my suggestion here is that when you try to solve this question, think of the formulae of cos 2 theta in terms of sine. Your job will be done. Your job will be done. So I've given you one more hint. You try it by yourself at home and you'll be able to do it. Trust me, mark my words. I have complete faith in my abilities. You will also be able to do it. Shall I move ahead with the next category of functions or properties or rules? But before we do, let's take a 10 minutes break and then we'll resume. So we'll resume at 9:50. Is that okay? So it's a break. We'll resume in 10 minutes. After 10 minutes, the class will restart. The only request I have is walk, roam around, stretch yourself, hydrate yourself, eat something if you were not fed well, and then come back after 10 minutes. Everybody? So let's meet after 10 minutes. Let's take a break and then we'll resume after 10 minutes at, let's say, 10:52. Okay, so here we are. Can you all hear me? Can you all see me? Shall we get started, everyone? Shall we resume? Everyone, can you all hear me? Come back if my voice is audible, if you all can hear me. If you're around, the system is open, the mobile phone is there or the laptop is there. If you all are there somewhere around, come back, everyone. I'm sure you must have had some water, you must have stretched, and you must have eaten something if you were tired. And let's resume, shall we, everyone? So far, are there any doubts, queries, or concerns? Whatever we have done, we have simply defined ITF, their domain, their range, and a very basic property f of f inverse of x is not just x always, especially in the case of ITF. You need to take care of the domain, right? You need to take care of the domain. So, shall we do the next case? Here, it's opposite. So what do you mean by its opposite? So far we were dealing with sine of sine inverse x. Now we were dealing with sine inverse of sine x. Is it same or opposite? Tell me. Can I again think it like this, that sine inverse and sine can nullify each other and I'll be left with x? Think again, think again, think again. Logically think again. And if you are able to process, write your response in the comments. I'll be really appreciating it. I'll be drawing the graph of sine inverse of sine x very soon. But before I do that, tell me, can I just think of it like this, that sine inverse and sine will nullify the impact and you'll be left with x? Will it really happen? And I think there is a problem. So what's the problem? You forgot something. Imagine this. Please understand this. Let's say if you are thinking that sine inverse and sine will nullify the impact and you'll be left with x, then what's wrong here? See, x as an input is passed to sine. Absolutely true. Yes, that's true. So if x as an input is passed to sine, I think sine can take any real value. So I'll say that x can be any real value. Yes, that's absolutely correct. Nothing wrong about that. Now, if any real number I pass as an input to sine, sine produces an output between -1 and 1. That's also true. That's also true. That sine of any real number gives you an output between -1 and 1. It keeps on hovering between -1 and 1. Little stars, cos inverse also has the same range. Cos inverse or cos? I think you're asking cos inverse. In that case, it is 0 to pi closed interval. So here, the problem is sine x is taking values from -1 to 1. And these inputs are now passed to sine inverse. So sine inverse is taking these inputs -1 to 1. So what is the range of sine inverse? Sir, sine inverse, when takes inputs from -1 to 1, produces the outputs from -pi/2 to pi/2. So ultimately, the values of y, which I'll be seeing getting produced, are going to be between -pi/2 to pi/2. So what's my whole point? What's my whole point? Sir, you said that as an input, any real number can be passed. Yes, we got it. But I'm also saying that as an output, only the values between -pi/2 to pi/2 can be attained. So what I'm able to process here is that if I visualize the graph of y is equals to sine inverse of sine x, I will be seeing the existence of the graph everywhere on the x-axis. But if I notice the graph on the y-axis, it will still lie between these two values, -pi/2 to pi/2 only. Are you able to process this idea? First of all, did you all get this? And one thing again, you all should process or understand is that there is a catch. So what's the catch? That sine inverse of sine x, if you wish to write, if you wish to define y is equals to sine inverse of sine x. Pay attention, everyone. Here we said that x could take any real value from -infinity to infinity. Here we said that x could take any value from -infinity to infinity. Absolutely fine. Okay with that. But are you noticing that here in this case, the outputs are going to stay between -pi/2 to pi/2? So as long as x is between minus pi by 2 to pi by 2, as long as x is between minus pi by 2 to pi by 2, as long as x stays between minus pi by 2 to pi by 2, in those cases only, sine inverse will be nullifying sine. Absolutely. Area under the curve when you solve, these will be really important for you. So I repeat, what did I just say? I said that if you want to claim that sine inverse of sine x is x, it's not always true. It's true only when x is between minus pi by 2 to pi by 2. Otherwise, you have to make some adjustments. Sir, what do you really mean by those adjustments? Those adjustments means I'll use the cyclicity here. I'll use the periodicity of these trigonometric functions here. Sir, what do you really mean by that? Let me help you with this. Let's say I take a value between pi by 2 and pi. I take an angle between pi by 2 and pi. Please pay attention, everyone. Pi by 2 is approximately 1.57. Pi is approximately 3.14. So between 1.5 and 3.14, let's say there is a value 2. What if I ask you to find the value of sine inverse of sine 2? Please, my dearest, sincerest siblings, younger brothers and sisters, you don't have this assumption that sine inverse and sine will nullify each other and you'll be left with the answer as 2. That's wrong. That's mathematically incorrect. You try and process this idea in your brain. You imagine this in your brain. Whatever this input is, it is perfectly acceptable. That when passed due to sine gives you a value between -1 to 1. That is also perfectly acceptable for sine inverse. But when sine inverse takes the values from -1 to 1, what does it produce as an output? What is its principal range? So sine inverse produces the output. Sine inverse produces the output. Sine inverse produces the output between minus pi by 2 to pi by 2, which means here this 2 should have stayed between approximately minus 1.57 to 1.57, but that's not happening here because 2 is clearly greater than 1.57. This expression can be mathematically wrong, but I hope you're understanding my point. What is my point? That 2 here is clearly not in that range. And that's a problem. Beautiful little stars. Good. Good. Excellent. Pi minus 2. Now why? Please understand, if I introduce a very simple observation here, sine inverse of sine 2. You tell me one thing. Do we know that sine pi minus theta is sine theta? I hope that I need not teach you because this is where you see pi. So pi minus theta will push you in the second quadrant where it is already positive. Yes or no? Everybody getting? So there, if it is sine inverse of sine 2, what will I do here is, I will take the benefit of this property here and I will write it as sine inverse of sine pi minus 2. Sir, why specifically pi minus 2? Why not 3 pi minus 2? Why not 2 pi minus 2? Why not 4 pi plus 2 or anything like that? Why specifically pi minus 2? Why? Yes, Little Stars has given us the reason for that as well. I'm glad you're doing it. Brilliant. And other students are also processing it, but I hope you're getting it. Pi minus 2. Why are we doing it pi minus 2? I hope pi minus 2. Pi is 3.14. 2 is 2. 3.14 minus 2 is approximately 1.4. 1.14. And that's clearly lying between this principal range. So if I do this pi minus 2, that brings us in that zone. Now, since I have gotten this value, I could write 2 as pi minus 2. And now I know that pi minus 2 clearly lies or takes a value between minus pi by 2 to pi by 2. And if that happens, there I say, that sine inverse and sine can be nullified because this value over here lies between minus pi by 2 and pi by 2. So if this value now, by using periodicity, by using cyclicity, I said Sine 2 can be written as sine pi minus 2. So nothing has changed so far, but one very beautiful observation has happened is or taken place is that now this pi minus 2 lies between minus pi by 2 to pi by 2. And if something like that happens, I can now nullify the sine inverse by the sine, and my final answer will be pi minus 2. Did you all get this? Were you all able to process this? Everybody got it. Everybody comfortably understood it. That's my whole point. That if I ever deal with values between pi by 2 to 3 pi by 2, I will say that sine inverse of sine x will not be x, it will be pi minus x. If the values are between 3 pi by 2 to 5 pi by 2, then my values of sine inverse of sine x will not be x, it will be x minus 2 pi. The logic of periodicity, cyclicity I'm using. But sir, how are we going to really remember all these lines? How are we going to form them? Now there are two methods. One method, you look at the pattern, you crack it, and then you make it every time. But that will be very lengthy. That will be very lengthy. So, sir, how do we do it? Let me try and teach you with some examples. Shall we try these questions here? Shall we, everyone? Let us learn it with an intuition-based approach. Sahityan is asking, when will the class end? Sahityan, you are in 11th standard. First of all, this is a 12th class topic, but still, if you're asking me to closure of it, I think this one shot will not be enough for ITF. I'll be splitting it into two parts. I know the importance of this chapter and the gravity it requires, the conceptual understanding it requires. So I'll be covering it in two parts. But today I'll be taking it at least till 12 o'clock at midnight. And around that, I'll be concluding it. So half of the chapter may get covered. Remaining half will do some other day. I mean, in the next week, possibly. But today, I'll take it to a great extent so that you understand the basics of it. Shall we move ahead from here? Now, the next thing which I'm trying to tell you is that first question. Now, you just tell me one thing, sine inverse of sine 1. What do we mean by that? What do we really mean by that? Sine inverse of sine 1. Sir, here if you pay attention, look at this one. Is this one lying between minus pi by 2 to pi by 2? Yes, sir. Yes, sir, it is. Why? Why? Because minus pi by 2 is minus 1.5, 1.5. So it lies between minus 1.5 and 1.5, which means what? Here I can take this benefit that sine inverse and sine will nullify each other, and my final answer will be 1. Yes, you can do that. But I think this we have just done. Second question also we have done. Sine inverse and sine 2 cannot nullify each other because 2 does not lie in this range. Yes or no? Remember that question we have already done. The second one. In the second one, all I'm saying is it is not 2 because 2 clearly does not lie in that minus pi by 2 to pi by 2 part. So there I'll use cyclicity. Yes, it is radian. Good. So there if I use cyclicity, I'll say another method I'm suggesting here is sine inverse of sine 2. So 2 I'm keeping as it is. I'm doing one thing, pi minus pi plus 2. Can I do this? Everyone okay with this? Is it still as same as sine 2? Yes or no? Is it still as same as sine 2? Did you all get it or shall I repeat it? Everybody. Everybody, are you all getting it? What did I do? I am saying that sine inverse of sine 2 I'm given. To this 2, I add and subtract pi. I hope nothing wrong has happened with this. But what is the advantage of doing it? Pay attention, everyone. If I take or rearrange it in a little better manner, I'll get it as sine inverse of sine of pi I keep outside minus sine if I take common from here. I'll be left with pi minus 2. Sir, why did you really do this thing only? Because by doing so, what I got was that pi minus 2, 3.14, 2 radian. So 3.14 minus 2 is 1.1, which is clearly in that range. And sine pi minus theta is sine theta, so I think my job is done. I'll say it will be sine inverse of sine theta. Sine pi minus theta is sine theta. So it will be sine pi minus 2. Getting my point? This is that method which you can apply if you don't know the graphs, if you don't want to learn the graphs, if you don't want to remember all those different values on different lines, if you don't want to get into those nuances. By using the cyclicity or the periodicity of these graphs, you can crack them like this. So with this, I think pi minus 2 now clearly 2 does not lie, but I hope you are processing this that pi minus 2 does lie. And if pi minus 2 lies between that, sine inverse and sine will nullify each other's impact and I'll be left with pi minus 2. Are you able to think like this? Shall I get the third question done? And with this third question, I'll assign fourth question as a homework question too. And as I've been constantly mentioning, all of these questions, notes, everything you can avail by following our WhatsApp channel. The link is given in the description. The third question, if I could try. Here again, there is a problem. If you want to do it with that method, sir, which method? With this method, this graphical method, you could crack it within seconds. You just need to remember the graph. Where is the graph? Here it is. You just try and find where would the 10 lie. So 10 is somewhere around 3 pi. Why? Because pi is 3.14. Sorry. Did I make any mistake? 10 is what? Yes, 10 is around somewhere around 3 pi. Because pi is 3.14. So 3 into 3.14 is somewhere around 9 point something. So wherever you find 3 pi, 10 will be just ahead of it. That is one of the methods. But sir, locating it would be a tough task because this is such a simple number 10. What if a very huge number is given to us? Are we really going to follow this pattern? No, of course not. Then I'll still suggest that follow this standard approach. It is really helpful. What am I saying here is that you help me with 3 pi, an approximate value of 3 pi. So pi is 3.14 into 3 is what I'm asking. So 3 into 3 is 9 and 14's triple is 42. Yes or no? So this is approximately 9.42. Getting my point, everyone? 3 pi. So I need to reach close to 10. I need to reach close to 10. So what I'll say is that here, if I do again one thing, sine inverse of sine of, if I add 3 pi, if I subtract 3 pi, and if I add 10 to it. I hope that can be done. Yes or no? Everybody getting it comfortably. With this idea, if I again follow the same process, sine inverse of sine of 3 pi, I take like this, minus sine if I take common, it will be 3 pi minus 10. Everybody got it, or shall I repeat it? Everybody comfortably getting it, whatever I'm doing here? Any confusion so far? Now with this, I hope I need not tell you 3 pi is clearly here. So 3 pi minus anything. You can understand? 0, 2 pi, 4 pi, pi, 3 pi, 5 pi. 3 pi minus anything pushes you in the second quadrant. So 3 pi minus theta is theta sine. I hope you're getting it. So here I'll write it as sine inverse of sine 3 pi minus 10. By the way, if I ask you what is 3 pi minus 10, so I hope you're realizing 3 pi minus 10, whatever it is, 9.42 minus 10, approximately 58, 0.58, I mean to say, 0 minus, of course, 0.58. So that clearly, this value clearly lies between minus pi by 2 to pi by 2. Because this is minus 1.5, this is plus 1.5. Processing it, everyone? Are you digesting it, everyone? So with this idea, this value since lies between minus 1.5 to 1.5, technically minus pi by 2 to pi by 2, then again I notice that this sine inverse and sine can nullify each other and I'll be left with 3 pi minus 10. So that's the answer over here. Sine inverse of sine 10 is not 10, it is 3 pi minus 10. So based on that, will you try this question by yourself now? Will you be able to crack it? I hope you must have understood the pattern, noticed the pattern, and understood the logic. Shall we move towards the next one? Cos inverse of cos. Again, follow the same process. X says I can take any real number. Cos says I will produce a number between minus 1 to 1. But cos inverse says when you pass me an input between minus 1 to 1, I'll produce an output between 0 to pi. Remember that principal range of cos inverse x? Yes or no, all the participants? So in sine inverse x, the output was getting produced as minus pi by 2 to pi by 2. In cos inverse scenario, the output will be from 0 to pi. So here if I notice the graph, x said I took all the values from minus infinity to infinity, which was fine. But y said I'll take values from 0 to pi. So I'll notice the graph from 0 to pi only. Everybody able to process it? Yes or no? Again, do I really need to say that between 0 to pi, if x lies between 0 to pi, cos inverse will nullify cos and I'll be left with cos. What's my point? My point is cos inverse of cos x I can write as long as x is between 0 to pi. So previously in the scenario of sine inverse of sine x, my primary task was to bring x between minus pi by 2 to pi by 2. In case of cos inverse of cos x, by using periodicity or cyclicity, my job is going to be bringing x between 0 to pi, approximately 0 to 3.14. Understanding that approach which I'm trying to suggest here, the idea which I'm trying to bring here, yes or no? Thank you so much, Arivu, for such a constructive feedback. Thank you so much for your words of appreciation. Thank you so much. There are barely 6 months left for the first attempt. What message do you say for the aspirants? Keep solving previous year's questions, Arivu. Whenever you go through a session like this, whenever you revise a particular chapter, the only request I have is solve previous year's questions. They'll help you in developing better. They'll give you more clarity, a better clarity. Comfortable, everyone? So with this idea, general solution also I could have produced cos inverse of cos x is y. So cos y will be cos x. So y will be given by 2n pi plus x. We remember cos theta is cos alpha. Then theta is given by 2n pi plus alpha. That general solution theory can be applied. With that, this is a clearly straight line. N can be 1, 2, 3, 4, 5, so on. So that's how you get these straight lines and you'll be able to draw these graphs. That's a little complicated idea. Rather, I'll suggest you to apply your brain. How? Let's solve certain questions. Naitik Mehta, for that, you should have watched this session from the beginning, although you have missed the initial part, I think. So what I'll suggest you to do is, once the session gets over, re-watch it from the beginning. In the very first hour of this entire session, I have covered that part only, that why are we restricting the domains? So that they become bijective, they become 1, 1 and onto. If they become 1, 1 and onto, their inverse can be defined. Imagine this. What is this far? What is going on with your generation? I'm seeing it a lot of places. What is this far? Can you explain this to me? Can somebody explain far to me? What is FH? What is it? I don't understand this. Somebody please explain this to me. As the teacher, I have been explaining a lot of things to you. Can you explain this to me? Please. So with this, because I think previously also somebody commented this word. Is it a new slang or something in your among your your people, your age group people? So I think I need not say anything about this first question because I think we have already done this. Why? Because 3 is clearly, I'm really sorry, 3 is clearly a number which lies between 0 to pi. Yes or no? Pi is 3.14. So if 3 is clearly a number which lies between 0 to pi, what will I say or do here? Sir, I'll say one simple thing, that here 3 lies between 0 to pi. So I will not hesitate in saying that cos inverse and cos will nullify each other. You will get the answer as 3. Techie, in that case, that's a natural phenomena that if you're struggling with the JEE Advanced questions, but if you are comfortably able to do JEE Mains questions, good. Struggle with JEE Advanced questions. They are made in such a manner that you struggle with those questions. Even we as teachers do. So it's a very natural phenomena. A lot of things happen simultaneously in those questions. So it's a very natural thing. Trust me. Nothing wrong about that. It's a very natural thing. The best thing is you are solving those questions, you are struggling with those questions, and more importantly, you're getting something out of it. But yes, you should decide a certain timer. I'll try this question for a certain time. And if I don't get the answer, I'll look at the solution. And then after going through the solution, attempt that question one more time. Rather, if you find that question to be still more difficult or a very good question, keep it marked so that in future, you don't go through all the questions in terms of revisions. You just go through those good questions which you have kept marked for your revision. Coming back to this idea, all I'm suggesting is that here the whole problem is that this 4 is not between 0 to pi. So what do? I use cyclicity. How? Let's talk about this. Cos inverse of cos 4 I want. So shall I say cos inverse I keep as it is? Cos 4 Now 4, if I wish to bring, can I say 4, if I subtract it or add it to pi? So the problem will be if you bring pi in the picture, I think it will do the job, but it will do the job in a little complicated manner. So shall we introduce 2 pi? What is 2 pi? So 2 pi is approximately 6.28. So from 2 pi, if you subtract 4, you are subtracting 4 from 6.28. So it is approximately, I think, 2 point something. I'm not very much interested in that exact value. It is technically 7.2, yes or no. But still, my whole point is, I hope you're getting it. I hope you're clearly getting it. If you are able to do JEE Advanced questions in 10 minutes, then you are going at amazing pace, Techie 123. It's better than normal, trust me. Yes, 40 marks are okay. In maths, they are amazing actually. In maths, being very genuine and honest. So I am saying 2 pi minus 4 if I'll do, I think I'll be in a better position. So let me do this. Here, I'll add 2 pi to it and I'll subtract 2 pi to it. To what? To 4. I hope you got my point. Everybody understanding this? 2 pi I have added and subtracted to this 4. Now the next thing which I'll do here is cos inverse I'll keep as it is. This cos I'll keep as it is. But here inside 2 pi, if I take minus sign common, it leaves me with 2 pi minus 4. Everybody processed it. I hope I need not tell you that here you will find 2 pi minus pushes you in the fourth quadrant. Cos is positive. So what do we get? We get cos inverse of pay attention everyone, 2 pi minus theta is cos theta in the fourth quadrant. So it will leave me with 2 pi minus 4. Everybody got it. Everybody could process it. Everybody is able to think now. So with this, I hope I need not tell you, 2 pi minus 4 is clearly 2 point something, which clearly lies between 0 to pi. So I think that's an acceptable value where cos inverse and cos can nullify each other. By using cyclicity and periodicity, we have brought this to here. And I think that's my answer, which is 2 pi minus 4. Everybody comfortably understood it. Everybody comfortably got it. Or do you need more explanation on this? With this, now, can I take the liberty to give you these two questions as homework questions now? Will you try the third and fourth question as homework questions by yourself at home? And after solving these questions, I'll be hoping and expecting that you write your answers in the comments. After the session gets over, you. Great, little sir. Naitik Mehta is asking, so the questions you are solving, can type of it asked in mains or advanced? This is the basis, the foundation on which questions will be created or formed. As we have promised, that we'll be covering the chapter Inverse Trigonometric Functions for JEE Mains and Advanced through one shot. It is such an early stage that the chapter has already started in class 12th. Many of you may have created it as a backlog. And we personally, clearly believe that one shots are never sufficient enough for JEE Mains and Advanced. For Advanced, never, not even for JEE Mains. They work really well if you treat them for revision, not for studying for the first time. If you are studying IT for the first time through a one shot, it's a terrible idea. So if you're watching a one shot for the sake of revision to covering a chapter as a backlog, then it's a clear request or advice or suggestion that once the session gets over, you solve the previous year's questions. And that's how you develop the idea that what kind of questions are asked. But this will work as a foundation, the basis. After this, you will become eligible or capable of solving JEE Mains questions. Trust me. And very soon, gradually, you will develop that ability from this chapter. That's the motive, intent, or the agenda, or the idea of this session. If I could clarify. Shall I get back to this? So these two questions, I hope you know the modus operandi, you know the approach, you know the idea. How should we approach? Little Stars has already given us the answer. That's beautiful. That's interesting. So I hope you will try these questions by yourself now. Will you, everyone? Good, great, excellent. With this, let me move towards the next part, 10 inverse of 10x. So we have finally the spammers with us. Let me just get those spammers removed so that we can stay focused. What is happening to my mouse? My mouse cannot block spammers. So there we are. Shall we resume? Here we are. tan inverse of 10x. If I'm dealing with tan inverse of 10x, what do we do here? Give me a moment, students. So here, tan inverse of 10x. Sir, again, the very basic idea. What's the idea? 10x. Sir, x can take all the real numbers in the world. Yes, because x is passed as an input to 10. Indeed, that's true. That's totally true. With this input, 10 gives you the output. 10 gives you the output, all the real numbers from minus infinity. Minus infinity to infinity. Yes or no? Now, from here, I hope you do realize that minus infinity to infinity, whatever input you give to tan inverse, tan inverse will produce outputs from minus pi by 2 to pi by 2 open interval. So in terms of domain, I'll say on the x-axis, I'll see the graph from minus infinity to infinity without any hesitation or problem. But sir, in terms of range, I will see the graph from minus pi by 2 to pi by 2 only. And the most beautiful thing here is the graph is simply this straight line getting repeated periodically. Getting it, everyone? And the whole thing remains very simple. As long as x remains between minus pi by 2 to pi by 2. I repeat, as long as x stays between open interval minus pi by 2 to pi by 2, I'll say tan inverse of 10x will be x. Look at this. So again, as we have been doing with cos inverse, sine inverse, I'll do the same idea with this thing as well, that with the tan inverse of 10x, if I could bring x between minus pi by 2 to pi by 2, if I could bring it between minus pi by 2 to pi by 2, then I will be considering my job to be done. Because with this thing, I think will be done. Let us stay focused. Take E1, 2, 3. Yes or no? Shall we stay focused? So again, I'll be using the cyclicity for cot inverse, cosec inverse, and sec inverse as well. This part, I think even if I skip and don't prove, you get it. Cot inverse stays between 0 to pi. Cosec inverse stays between minus pi by 2 to pi by 2, except 0. And sec inverse of sec x stays between 0 to pi, except pi by 2. If you didn't get my point, I'll keep it very specific, direct, and conclusive that here, sine inverse of sine x, you would call x as long as x is between minus pi by 2 to pi by 2. Now, are you realizing it that if I'm keeping x between minus pi by 2 to pi by 2, then only I'm able to achieve this. So this part, I hope, is totally relatable with what we did in the beginning. That table I created and I told you to memorize it. That will be really helpful and beneficial here if you do it. Getting it, everyone? Yes or no? Now the next part. Sir, can the same be done for cos? No. For cos, I'll suggest you to write as cos inverse of cos x will be x as long as x is between 0 to pi. Now, what did I suggest you? Sine, tan, cosec, stay on the same page. A little same. And cos, sec, and cot stay on the same page. What does it mean? If I am told tan inverse of 10x to be x, then I'll say it will be true if x is open interval minus pi by 2 to pi by 2. Similarly, if I am told cot inverse of cot x, so I'll call it x as long as this x is between open interval 0 to pi. So I'm still showing you some symmetry so that you can learn them more quickly. So you can remember them with this pattern here. For example, here in this part, sine inverse, tan inverse, I told you cosec inverse of cosec x. So this also I'll call x as long as this x stays between closed interval minus pi by 2 to pi by 2, except for 0. And I hope you know the reason why. In the same manner, cos, cot, and sec inverse of sec x will be x as long as as long as x is taking values between 0 to pi closed interval, excluding pi by 2. So are you able to relate these results? That why did I club these three together? Put them on one side. Why did I club these three together? Put them on one side. Just because of one single reason, which will help you in memorizing, them. This part, are you able to make some sense out of it? Are you able to make some sense out of it? Yes or no? Everybody getting it? Everybody understanding it comfortably? Any confusion so far? Any queries so far? Ask me if there are any doubts, queries or concerns. Shall I move ahead from here? Yeah, कुछ comments block कर देना. Comments के and users को block कर देना. ऐसे ये बदतमीजी कर रहा है, हटा ही देना इसको. इसको हटाना. ये लास्ट वाला, ये सब दो चार जो हैं लास्ट के सबको हटा दो. हाँ, ये दो चार हैं, ये स्पैमिंग ही कर रहे हैं, सबको हटा दो, ब्लॉक कर दो. Okay. Shall I move ahead from here, all the participants? Everybody, any confusions or queries? Able to digest this? And are you realizing that this whole makes complete sense if you remember this part? And this part is coming from where? This whole thing is coming from that idea which we developed by creating that table. Remember that? Yes or no? Shall I move ahead from here, all the participants? Any queries or confusions? Any queries or confusions? Okay. Shall we resume? I hope so far there are no concerns. Let us get more clarity on whatever we have done so far with these questions. Everybody, look at this. This question over here says tan inverse of 10 2 pi by 3. Now, sir, tan inverse of 10 2 pi by 3. Can I just say that, sir, this tan inverse and 10 will nullify each other and my answer will be 2 by 3? I think you're too quick to conclude that. Have you noticed, or have you observed, or have you seen this, that this 2 pi by 3, whether it lies between minus pi by 2 to pi by 2 or not? Remember this thing only I'm extending here. Tan inverse of 10x will be written as x as long as x is between minus pi by 2 to pi by 2. So is that happening over here? So 2 pi by 3, I hope you do accept pi by 3 is clearly 60. 60 into 2 is 120 degree it is. 120 degrees more than 90. So, sir, there is a problem. First of all, 2 pi by 3 is more than pi by 2. So, I think there is a problem. Okay, sir, then what do we do? In that case, I'll use cyclicity or periodicity of these functions. Sir, how? Let's talk about that. So, here what I'll do is tan inverse of 10 of 2 pi by 3. Can I write it as either pi minus pi by 3? Trust me, that will work. Or if you want to use some other versions, you can. But I think pi minus pi by 3 is the best practice here. So can we really do it? Yes, have patience, just let me do it. You will notice something really amazing. So 2 pi by 3, I hope without any hesitation, we can write as pi minus pi by 3. Yes or no? Tell me honestly. We can. So with this, here we are, tan inverse of 10 of. Now tell me, 10 pi minus theta. Second quadrant, 10 is negative. So will I not be writing it as minus 10 pi by 3? Now this thing I'll teach you later, but right now we are using it. That's why I'm telling you that tan inverse of minus x can be treated as minus tan inverse x. One of the reasons is tan inverse is an odd function, sine inverse is an odd function, cosec inverse is an odd function. So one more value or input I'll add here. Please understand, sine inverse of minus x can be written as minus sine inverse x. Cosec inverse of minus x can be written as minus cosec inverse x. And tan inverse of minus x can be written as minus tan inverse x. These three are odd functions, considering their principal domain, which means here minus x minus x minus x should, in this case, lie between minus 1 to 1, closed, here in this case lie between less than minus 1 or greater than 1. Here minus x should lie between minus infinity to infinity. But here in these case, they are not even. I mean, if you are thinking that sir, these are odd, they should be even. No. Which means here, if I am asked to deal with cos inverse of minus x, I'll write it as pi minus cos inverse of x. If I need to deal with cot inverse of minus x, I'll be writing it as pi minus cot inverse of x. If I need to deal with sec inverse of minus x, sec inverse of minus x, then I'll be writing it as pi minus sec inverse of x. Sir, why is it happening? Why are we really doing it? I'll explain it with a proper proof, don't worry. But right now, since we are using it in a question, I'm telling you. So keep it with you as we have just kept these. But here also, I'll be hoping that you can see some similarity or pattern. And that's how I'm constantly asking you to keep them categorized so that this pattern will help you in remembering them in a more easier manner. Here also, the domain part you need to take care of. This minus x should stay between minus 1 and 1. This minus x should stay between any real number. And this minus x should stay either less than minus 1 or greater than 1. Sir, in this question, what are we doing? In this question, we are dealing with tan inverse of minus x, which I'm asking you to write as minus tan inverse x. So here in this part, tan inverse of minus x. So this minus can be treated or taken outside because of it being odd function. So minus of tan inverse of 10 pi by 3. Yes, there can be some other ways because it is cyclic and periodic. You could have used some other variants and versions as well, but this is also one of the methods which you can undoubtedly use. Now comes the most interesting part. I hope you are realizing pi by 3 lies between minus pi by 2 to pi by 2. So tan inverse can nullify 10 and then I'll be left with minus pi by 3. Everybody understood it. Everybody got it. Any confusion so far, or shall I repeat it? Give me a quick response. Shall we move ahead from here, all these students? With this, let's try one more question, tan inverse 10 of minus 6. Or rather, shall I give you this as a homework question now? First of all, let's say you want to get rid of this minus sign. So 10 and tan inverse both are odd. So their composition will also be odd. So first of all, if you are not very much comfortable with this minus, you can directly write it as 10 minus of tan inverse of 10 of 6. I think we have just learned to deal with these kind of questions. Yes or no? We have already done this category of questions. Sir, here the problem is this is 10, 6. And for 10, we want to ensure that this angle over here stays between open interval minus pi by 2 to pi by 2. So if I could bring this 2 between minus pi by 2 to pi by 2, I'll consider my job to be done by using cyclicity or periodicity of trigonometric functions. So how are we going to achieve it? I think the basic idea is 6, crack it. I think 6 is clearly somewhere close to 2 pi. I hope you understand 2 pi is clearly double of 3.14, which is 6.28. So from 2 pi, if I subtract 6, I think we are very close to something 0 point something. We are not very much interested in that value. But I'm sure 2 pi minus 6 will be something positive. It is, I think, 0.28 technically. 6.28 minus 6 approximately is 0.28. So this clearly lies between minus pi by 2 to pi by 2. So I think 2 pi minus 6 is what I'll try to create here. How? I'll say this minus stays outside. I don't bother about that. So 10 inverse of 10 of this 6. Can I write it as 2 pi minus 2 pi plus 6 without any hesitation? We can do so. Yes, that's not a problem because 2 pi gets cancelled. It is still that same original expression. But having said this thing done, we are having tan inverse of 10 of. If I take this minus sign common, I'll be left with 2 pi minus 2 pi minus 6. Yes or no? Is it visible to everyone? Is it visible to everyone? Yes or no? So what did I just do? 2 pi I took here, minus sign if I took common, it is 2 pi minus 6. Now, here we are. 2 pi minus theta. Can you help me with 2 pi minus theta, everyone? What is 2 pi minus theta here, students? What is 2 pi minus theta? What is 2 pi minus theta for 10? Sir, fourth quadrant. In fourth quadrant, 10 is clearly negative. I think we are done with this question. I have already a negative sign outside. This gives me another negative. I think that gets balanced. That gets totally and completely balanced, and my question stays very much sorted. Because this minus, 10 inverse being odd, comes out. This minus and this minus becomes positive, and then I'm left with 10 inverse of 10 of 2 pi minus 6. As we have just concluded, 10 of 2 pi minus 6. Look at this 2 pi minus 6. It stays between minus pi by 2 pi by 2. So now 10 inverse and 10 can nullify each other, and my final answer will be 2 pi minus 6. I'm sure some of you must have cracked it. Excellent, Dhruti. And I'm sure other students, those who are watching it sincerely, must have gotten the whole logic. There are multiple other approaches as well, which you could have applied or thought of or done. We are completely okay with that, but this is just one of those methods which can also be applied. The only advantage I'm taking right now here is solving them by using the periodicity of these trigonometric functions so that I can bring them in their principal range and my job is done. Everybody understood that? The whole thing here, whatever we have done so far. Now, if I am given sine inverse x, let me just correct this part first of all. There is a small correction here. This is sine inverse x. This is sine inverse x where x is positive. That's a better statement. So here we are. If I'm given an expression y is equals to sine inverse x where x is positive, and I want to express it in terms of other trigonometric functions, inverse trigonometric functions, then how do we do it? I will take a very simple example so that it becomes more understandable. Let's say here, a very basic example I'll take. Let's say I'm given y is equals to sine inverse of any value, let's say 1 by 3, right? This is what I'm given. So can this same y be represented in terms of cos inverse, tan inverse, cot inverse, sec inverse, cosec inverse? Yes. First of all, ensure that this 1 by 3 is positive so that you don't face any issues with the conversion part. Now for a while, let's say this sine inverse 1 by 3. I hope you are realizing 1 by 3 is a value and sine inverse of 1 by 3 will be an angle. So I can treat sine inverse 1 by 3 as theta, or you may say that sine inverse 1 by 3 is y. So sir, you could have concluded that sine y is equal to 1 by 3. Absolutely fine. Which means what? Y is technically an angle whose sine ratio when you take returns you 1 by 3. Now what if I take a right angled triangle in which there is an angle which is y? So in terms of ratios, I can say perpendicular and hypotenuse. So this is 1, this is 3. Base by Pythagoras, if I try to work out 9 minus 1, 8, square root of 8 is 2 root 2. So this will be 2 root 2. Everybody comfortably got whatever I've done so far. Now, sir, you tell me, with respect to this y, what are different ratios going to be? Can you help me with cos y? Sir, cos y is base upon hypotenuse, which is 2 root 2 by 3. Can you help us with the tan y? Tan y is perpendicular upon base, which is 1 by 2 root 2. Not just that, what if I ask you cot y? Cot y will be reciprocal of this 2 root 2. What about sec y? You would have said sec y will be 3 by 2 root 2. Sir, what would have been cosec y? Sir, that's very easy to predict. If sine y is 1 by 3, cosec y would have been 3. Sir, why are we really doing it? Has someone observed or noticed something simple, straightforward, which I'm trying to tell you here? I hope you would tell me that, sir, y could, from this case, can be written as cosec inverse of 3. From this part, y can be written as cos inverse 2 root 2 by 3. From here, y can be written as tan inverse 1 by 2 root 2. From here, y can be written as cot inverse 2 root 2. And from here, y can be written as sec inverse 3 by 2 root 2. That's exactly what I've tried giving you in terms of formulae. You really don't have to learn the formulae. You just need to learn the logic. Have you all been able to process the logic? Have you all been able to understand the logic? Did you all digest it? Did you all get it comfortably? All the participants, is there any confusion regarding anything? So my whole point is really simple, that we started with this idea, that we took this, converted into this, created the right angle triangle, and based on it, I predicted or worked out all the other ratios, and with that, I could define their inverse. Is it not absolutely simple, straightforward, doable, considerable, and achievable? With this, what if I ask you to solve a question? Will you try a question here? Let's do it, everyone. Shall we? What does it say? Tan inverse x upon under root a square minus x square is needed to be converted. Again, there is a typo. I'm really sorry for this. Is needed to be converted into, no, there is no typo. In terms of sine inverse, where x is said to be positive, that means x is between 0 to a. So this whole thing remains positive. You need not worry about that. They have ensured it in this manner so that this thing remains positive. Because if x is between 0 to a square minus x square will be positive, square root of it will be positive. This is also positive, positive upon positive, positive. So this whole thing remains positive. So here, if you don't get it, I'll do it in a very childish manner. You really don't have to do it specifically for an exam like IIT JEE, but still, if you want to understand it from the scratch, this is how a teacher will explain to you. This tan inverse x upon under root a square minus x square, if I treat as theta, tan theta, I'm going to get as x upon under root over a square minus x square. Again, you can mentally apply Pythagoras here directly, but still if you need more clarity, you can say that, sir, if this is an angle theta, perpendicular will be x, base can be treated as under root over a square minus x square. Pythagoras will give you the hypotenuse. So what is going to be the hypotenuse? Under root over square of this plus this square. I hope you're getting it. So x square plus a square minus x square. So x square are cancelled. You will be left with under root over a square. That is mod a. A is already positive. So mod a will be a. Are you able to process it? Or do I really need to show how did I apply Pythagoras theorem here? Everyone comfortably getting it? Now with this conclusion in mind, if I talk about other versions, we have tan theta. Can you help me with sine theta here? I hope you all can. Sine theta will be given by perpendicular upon hypotenuse, which is going to be x upon a. So there, if I ask you theta, it will be sine inverse x upon a. So this theta, which was tan inverse of this, is the same theta which is sine inverse of x upon a. Absolutely, Dhriti. What about other participants who are watching it sincerely? Are you all able to process this idea? Are you all able to understand this concept? Are you all able to get it comfortably? Does it make complete sense that how am I converting one inverse trigonometric ratio to other trigonometric ratio? How are we really doing it? Are you all able to get it? Yes or no? Shall we try one more question? Let's see how many of you get it. Let's see how many of you get it. Shall we? And by the time I am done with this question, I'll be hoping that you are carrying a pen and paper with you and you're doing this by yourself as well, not by using AI or some other technology you have. You use your brain. So why should we use your brain? Because by using your brain, you will give it some opportunity to get developed. Otherwise, you may end up spamming like those other kids who are wasting their life and their precious time in spamming. Unbelievable. So, I mean, that's unbelievable. People on YouTube have the time to watch some random video and comment on it. Imagine this, you have a life. You are given certain years to live. And that's how you're spending your life. Commenting on somebody's videos. Keep it up. That's the purpose of your life. That's how you're wasting your life, I would say. So here I'm told sine of cot inverse of tan of cos inverse of x is x. I need to prove it where I'm told x is positive. So I'll use inside out approach. What is inside out? Cos inverse x for a while. Cos inverse x for a while if I treat as theta. I hope we can. So if cos inverse x is theta, this internal expression is tan theta. Yes or no? This internal expression is technically tan theta. If you want to write it properly, this is sine this is cot inverse, and this is technically 10 theta. Yes or no? Because cos inverse x I have taken as theta. So if cos inverse x we have taken as theta, will I not say that cos theta is x? Although from here you should be able to write 10 theta, but still if you are confused, what you could have done here is that you could have taken an angle as theta. Cos theta is x upon 1. So this is x, this is 1. So this will be under root over 1 minus x square. Getting it or not? I have perpendicular. I mean, I have base, I have hypotenuse. Pythagoras I'll apply and I'll crack the perpendicular as well. Yes or no, all the participants? With this, I think we have tan theta perpendicular upon base, which is going to be under root over 1 minus x square upon x. Got my point, everyone? Whoever is showering so much love, laugh, amazement, percentage, celebration, agreement, whatever you are showering there, thank you so much for being so nice. But may I know who this person is? So here we have tan theta. So will I replace this tan theta here? So I'll be getting this as sine of cot inverse of, what is tan theta? That is under root over 1 minus x square upon x. Got my point, everyone? Now what I do next is, sir, let's solve it further. Let's take it further. Okay. So when I wish to take it further, I'll do one more thing. Which thing? That here, let us say this thing, cot inverse of this, cot inverse of this, cot inverse of under root over 1 minus x square upon x. Let's call it alpha. Although you could have done it from here only, but let's say we do it like this. I'm treating cot inverse of this whole thing as alpha. So I hope you are understanding. Cot alpha will be given by under root over 1 minus x square upon x. So this is technically that same triangle. I hope you're noticing it. Alpha is what? Base upon perpendicular, because this is cot alpha. Cot alpha is base upon perpendicular. So base here is going to be 1 minus x square and perpendicular will be x. So if you know perpendicular and base, I think hypotenuse can be cracked quite easily. How? Sum of their squares inside and under root. So x square will get cancelled. You'll be left with 1. Square root of 1 will be 1. Hypotenuse will be 1. I will not take your name, Sumit Ojha, no matter how much you try. So here we are. Look at again this. I have told you in the beginning only that people have the time in their life to watch a random video and put random comments. And that's the purpose of your life, Sumit Ojha. That you're begging somebody to take your name. Think again. Anyways, cot inverse of this. So this whole thing I treated as alpha. So finally, what did I get? I get sine alpha. So my last objective is to write sine alpha. Can somebody help me with sine alpha? Sir, sine alpha is perpendicular upon hypotenuse. What will that be? Sir, it is going to be x upon 1. And that's exactly what we were supposed to get as RHS. We have proven it. Yes or no? Everybody understood the whole solution, the whole idea. I think this part I have already covered. I think I have already explained, so I'll not be taking it again. I hope you do remember. One thing is missing from here, the sixth one. So sixth one I'll write here. I hope nobody gets bothered by that. Sine, cos, tan, sec, cot. Cosec is missing. So cosec inverse of minus x will be minus of cosec inverse x for all x which are minus infinity to minus 1 or 1 to infinity. So I repeat, the idea is really simple. You club these three together. Which three? Sine inverse is an odd function. Tan inverse is an odd function. Cosec inverse is an odd function. Did you notice it? Everybody, did you notice it? And these three, cos inverse minus x is pi minus cos inverse x. Sec inverse minus x is pi minus sec inverse x. And cot inverse minus x is pi minus cot inverse x. Everybody with me on this? Any confusion so far regarding this? Now, I repeat, you need to remember this thing, that why are we having this? The very basic idea is that I hope you remember sine inverse of minus x, I need not explain, you know it very clearly, that let's say if I wish to prove it, if I need to prove it, can I do it here? let's say sine inverse of minus x I'm dealing with. Let's call it theta. So we know sine theta is going to be minus x. So I can say minus sine theta is x. So can I say sine of minus theta will be x? So can I say minus theta will be sine inverse x? So can I say theta will be minus sine inverse x? In the same manner, you can prove it for tan and cosec as well. But what's the problem with cos? Let me tell you that. Let's say I have cos inverse of minus x, which I treat as alpha for a while. So cos alpha, I'll treat as minus x. Pay attention, everyone. Pay attention. This is most crucial part. Cos alpha, cos alpha. Let me write it as minus cos alpha is equals to x. Now you help me that cos is of course an even function. So there is no point of taking this minus over here because it will get absorbed. So I don't write it like this. But one very beautiful and interesting fact I know is that cos pi minus theta is minus cos theta. So this minus cos alpha, I could have written as cos pi minus alpha. Are you realizing something very amazing here? That's the gist or the crux of this proof, I'll say. So here I'll say cos inverse x is pi minus alpha. Alpha I'll take here, cos inverse I'll take there. So alpha is equal to pi minus cos inverse x. What was alpha originally? Alpha was cos inverse x. Sorry, cos inverse minus x. So cos inverse minus x can be written as pi minus cos inverse x. That's what I wish to conclude. So the same result you can prove for sec inverse of minus x, for cot inverse of minus x. And this conclusion which we have given, which we have generated, that here, this part, sine inverse of minus x is equal to minus of sine inverse x. The same idea can be developed for tan inverse and cosec inverse. I hope you have understood the proof. And you will remember this slide as well. Take a screenshot of it because you're going to need it in future. There comes 3 more. JEE Mains and Advanced, specifically Advanced, has been asking questions based on it. To be more specific, this part. First of all, the basic ones, if I could tell you. Please pay attention, everyone. If I ever ask you if sine inverse is 1 by 2, don't hesitate in writing it as cosec inverse 2. You just need to ensure that whatever is passed as an input to sine inverse stays between -1 and 1. Whatever is passed as an input to cosec inverse stays between either less than -1 or greater than 1. Same idea, same philosophy, same logic you can apply to cos and sec as well. Let's say I'm told sec inverse 3. So I can without any hesitation write it as cos inverse 1 by 3. Again, I need to apply the same logic. Ensure that cos inverse input stays between -1 to 1, closed interval. Sec inverse input stays either less than -1 or greater than 1. So if this is x, this will be 1 by x. If this is x, this will be 1 by x. This is how sine and cosec, sec and cos are related. And I hope you are understanding the logic pretty well, as we have just learned the result. Based on that, we can clearly prove it. These are some really basic, simple and easy. Students commit mistakes in this specific part. Yes, please pay attention, students. Please pay attention, everyone. If I ever see tan inverse 2, notice this 2. Is this 2 positive? Yes, this 2 is positive. Then without any hesitation, you can write it as cot inverse 1 by 2. It is perfectly fine. And here there is nothing, no compulsion on this 2 and 1 by 2. You just need to ensure that this is a real number. To be very honest, this should be a positive. But sir, if you ever see something like, let's say, tan inverse -3. Here there is no compulsion like -1 to 1 or less than -1 greater than 1. All you need to ensure is it is a real number. No problem with that. But check whether it is positive or negative. If it is positive, don't hesitate in writing in its reciprocal in cot inverse. If it is x, it will be 1 by x without any hesitation, as long as x is positive. But the moment x becomes negative, you just don't do it like this. You add minus pi to it. What does it mean? Let me help you with this. Tan inverse of -3 will not be cot inverse -1 by 3. It's false. Tan inverse of -3 tan inverse of minus 3, try and imagine this or visualize this, will be minus pi plus cot inverse of minus 1 by 3. So minus pi plus what is happening over here? Give me a moment. Cot inverse of minus 1 by 3. Did you all get it? Everybody processed it. Everybody understood it. Or shall I repeat it? This is the most crucial part. This is the most critical part in which students commit mistakes. They are so much in rush in the examination hall that the moment they see 1 by x, they write it as x for cosec inverse, for cos inverse also, even for tan inverse also. You can do it as long as x is positive. But if x is negative, you need to bring an adjustment. Sir, why are we bringing this adjustment of minus pi? Why do we really have to do it? Why do we have to add this minus pi here? Okay, let me take you back to those curves. Which curves? Let's draw those curves. Then I will be in a better position to tell you these reasons. This is y-axis. This is x-axis. And here, let's say, this is a line passing on the y-axis through pi by 2. This is a line passing through pi. This is a line passing through minus pi by 2. Everybody pay a lot of attention. I'm going to tell you something very interesting. This is minus pi by 2 as a point. This is 0. This is pi by 2 as a point, and this is pi. Pay a lot of attention. I'm going to tell you something very interesting, and it will help you a lot in solving a lot of questions. And this adjustment I may not be explaining further for the upcoming formulae. So this is where I'll be telling you. Remember this, that for tan inverse, the graph goes like this. This is how you draw the graph of tan inverse x. So this is how I'm drawing the graph of tan inverse x, where we know it very clearly that it exists for all the real values of x, that is from minus infinity to infinity, but its output is open interval minus pi by 2 to pi by 2. Remember that whole thing, yes or no? Give me a moment, students. Let me just remove some unnecessary people who are just here we are. Now let us go to the graph of cot inverse x. I hope you remember cot inverse x graph. If I draw, it gets drawn like this. So this yellow curve is representing your graph of cot inverse x. This also takes inputs from minus infinity to infinity, but cot inverse x produces outputs from 0 to pi open interval. So I hope there is no doubt about it that this one produces the output from open 0 to pi, and tan inverse produces the output from minus pi by 2 to pi by 2. Now let me tell you what's the problem. Why did we really add this minus pi? Can somebody in the comments tell me that why are we putting this minus pi? What is the need of it? Why do we really need to do it? Can somebody tell me this? I hope some of you must have noticed something very important and beautiful and interesting over here. Some of you must have. Sir, as long as x is positive, as long as you are staying here on the right side of y-axis, for all these values, tan inverse x and cot inverse x, they both are between 0 to pi by 2. They both are between 0 to pi by 2. Which means if I ever say that x is positive, then I will not hesitate in saying that tan inverse x and cot inverse 1 by x would be same. Why? Because if x is positive, whatever output tan inverse x produces, the same output is produced by cot inverse. Look at the graphs. The graph of tan inverse, the graph of cot inverse. Both are between 0 to pi by 2. But have you noticed a problem now? Has somebody noticed a problem now? So what's the problem? If x becomes negative, then I'm sure some of you must have noticed, if x becomes negative, tan inverse, if x becomes negative, tan inverse stays between 0 to minus pi by 2, or in a very better language, minus pi by 2 to 0. But for negative values of x, but for negative values of x, chord inverse x stays between pi by 2 to pi. Now imagine this, you are, let's say mistakenly, you are mistakenly saying that tan inverse x is equal to cot inverse 1 by x for negative values of x. Then what's the problem you're making? What's the problem you're generating? Let me highlight that. Tan inverse x for the negative values of x is giving you the output from minus pi by 2 to 0. And cot inverse 1 by x, I hope you're realizing if x is negative, 1 by x will also be negative. So cot inverse 1 by x for negative values of x is producing the output pi by 2 to pi. Now, how are they justified? Do they really make any sense? Come on. This says I'll produce an output for negative values of x between minus pi by 2 to 0. Okay. By your thought of reciprocal, you said that it will be equal to cot inverse 1 by x, where x is negative, so 1 by x will also be negative. So if 1 by x is negative, for negative inputs, cot inverse produces the output from pi by 2 to pi. So sir, look at this. LHS is producing outputs from minus pi by 2 to 0. RHS is producing outputs from pi by 2 to pi. That's clearly a problem. So how do we resolve this problem? How do we, come out of this problem if I simply subtract pi from it? Now imagine if you have subtracted pi from it, pi by 2 minus pi is minus pi by 2, pi minus pi is 0. So I think if I subtract pi from it, LHS and RHS both produce the same range of outputs. And that's where my equation stays balanced. So why did I add a minus pi to it? Did you all get it? Able to make sense out of it? That's a very important and a very crucial formula, which if JEE Mains doesn't ask, JEE Advanced would. But trust me, JEE Mains will also ask it in one of the shifts, in one of the days, on one of the days. It definitely will. So did you all digest it? Did you all get it? Did you all comfortably process it? Or shall I repeat it? Everybody? Or do I really need to re-explain this whole thing? Everybody with me so far with any queries or confusions? Are there any doubts? Shall we move ahead from here, all the participants? Are we good to go? Everybody. Shall I move ahead from here? Then there are a few more. These are the most amazing ones. These are the most crucial ones. These are the most important ones. Let me just see how much are we left with so that I'll decide whether to conduct it in the next session or in this session only. So I'll probably try to complete it in this session only. I'll probably, and I should. Why should I not? So let us take another 10 minutes break and then we'll resume in a while. Will that be okay? So this is where we'll start again, resume again, but let me have a 10 minutes break and then we'll resume. So timer, I'm starting here. Will I will put it here. So I think this is seconds, this is minute, right? So we are starting this. Give me a second, everyone. I'm just starting the timer. Okay, so it has started. It's a break of 10 minutes. We'll resume after 10 minutes. Is that okay? So you also hydrate yourself, stretch yourself, walk a little, and then we'll resume in a while. 11:20 I'll resume at, okay? What a timing. What a timing. I coincidentally came exactly at 0. I did not plan it, but it happened. Anyways, so I hope my voice is audible, I am visible, and we can resume with our discussion. Everybody, can you all hear me? Can you all see me? Shall we resume? I hope I'm properly visible and audible to all the participants. Give me a moment. Give me a moment. There is something wrong here in this part. Let me just get rid of it. Hold on for a while, students. Don't know what was there. I hope it is. I'm finding it difficult to write here because there is some. I don't know what is it, but some. Okay, here we are. Shall we get started, everyone? Can you all hear me? Can you all hear me? Can you all see me? Shall we resume, everyone? Okay, great. So here we are. These are few more properties. Okay, so if I could explain one of those, it's very simple. It's very basic. It's very easy. You already know these from your trigonometric days, from your 11th standard days. So what does it say? It says, I hope you know that sine pi by 2 minus theta is cos theta. That's it. I'll use this information only. So for a while, let's say if I say, I hope you're getting it completely. Cos theta, if I treat as x, then I hope you are clearly realizing this whole thing I'm calling as x. So there, cos theta, if I call as x, theta will be cos inverse x. But if sine pi by 2 minus theta is also x, here I'll say pi by 2 minus theta will be sine inverse x. So this theta, if I replace by cos inverse, and cos inverse if I take there, I'll get pi by 2 as sine inverse x plus cos inverse x. With one constraint, one conclusion, one problem, one restriction. Can you help me with that restriction which we are imposing here? What is that constraint or condition or point or idea which we are applying here? Sine inverse x, cos inverse x. They both are taking inputs x. Sine inverse says I'll take input between -1 and 1. Cos inverse also says I'll take input between -1 and 1. So this will be pi by 2 only when x takes inputs between -1 and 1. There was a question in JEE Mains way back, which was somewhat like this. They asked the value of sine inverse 3 plus cos inverse 3. And the moment everybody saw it, sine inverse x plus cos inverse x, they simply wrote pi by 2, which was wrong. Why? Because technically speaking, sine inverse 3, I think we have been discussing it since the beginning of this session, that here, this 3 and this 3 will not be acceptable for sine inverse and cos inverse or by sine inverse and cos inverse. Did you get it? I repeat, sine inverse takes inputs from -1 to 1. This also. So sine inverse 3 and cos inverse 3 are not even defined. So this is clearly not going to be pi by 2. This is not even defined. Getting my point, everyone? So that's the logic here. That's the point here. That sine inverse x plus cos inverse x will be pi by 2 as long as x is from -1 to 1. Tan inverse x plus cot inverse x will also be pi by 2, but here tan inverse and cot inverse can take any real value. So it will be pi by 2. X can be any real value. And the third result, sec inverse x and cosec inverse x will also be pi by 2. But in this case, I hope you do remember, x has to be either less than -1 or greater than 1. Everybody processed it. Everybody got this idea. Everybody understood this conclusion. Yes or no, all the participants. Shall we try a question and get more clarity on this? Yes or no? So let's do a question here. What does it say? It says sine inverse x is pi by 5 for some x being open interval -1 to 1, open interval -1 to 1. Then they are asking you the value of cos inverse x. I think first of all, x is between -1 to 1. So one thing I know is that sine inverse x plus cos inverse x is pi by 2. I hope I can write it like this. It doesn't bother you. So if I'm asked cos inverse x, can I not say it will be pi by 2 minus sine inverse x? Comfortably getting it. But sir, sine inverse x is pi by 5. So sine inverse x is pi by 5. Cos inverse x will be pi by 2 minus pi by 5. Now here, I hope you can clearly see, this will be giving me LCM 10. This will be, I hope you're understanding, 5 pi. This will be 2 pi. Yes or no? I hope everybody is listening and watching and understanding. This is 5 pi and this is 2 pi. So 5 pi minus 2 pi is clearly 3 pi. So cos inverse x we have received as 3 pi. Any confusions or queries? And this 3 pi by 10 is clearly less than pi, because cos inverse x says that I will produce the outputs from what is happening 0 to pi. So this 3 pi by 10 has to lie between 0 to pi. It is indeed. So that is an acceptable value and it is my answer. Simple, easy, direct, straightforward, just to make you understand this application. Everybody processed it? Yes or no? Shall we try one more question so that we can get more clarity here? Absolutely, Dhruti. I'm glad you are there since beginning. It's very amazing. And I would really appreciate your efforts. I think you are somebody who's putting your genuine and sincere efforts. Brilliant, good, keep it up. And trust me, mark my words, if you are really doing it since the beginning of this session, so far, stay there till end, and you will get some really decent, understanding out of this chapter. I understand this totally, that we cannot promise or we cannot make these fake promises that after watching this one shot, you will get this chapter totally and completely and you'll be able to solve everything from JEE Mains and Advanced. That's a very bad promise or assurance somebody can give to you through one shot only. But yes, one shots are good for revision, good for covering your backlog. And after watching one shots, mains and advanced PYQs are must. Preferably first mains, 2020 onwards, last 6 years will be sufficient. And then JEE Advanced after 2000 onward, because JEE Advanced has limited questions every year. So you'll get a decent number of questions, quality questions. But those should be attempted once you have gone through JEE Mains PYQs. Coming back here. Sine inverse 1 by 5 plus cos inverse x, this whole sign is given as 1. Okay. Sir, simply talk about this thing. Can I take the benefit of doubt by stating that if sine of some angle is 1, can I not take this value as pi by 2? I think I should. Great. Excellent. Keep it up. If you're genuinely saying this, gaming 6398. So first of all, everybody got my point. Can I directly take it as pi by 2 instead of complicating it unnecessarily? Because what I'll do is, I'll say this is equal to sine inverse 1. And what is sine inverse 1? Pi by 2. So from here, an intelligent brain will say that this value here can be treated as this value here, sine inverse 1 by 5 plus cos inverse x can directly be treated as pi by 2, because I'll take the numerically smallest possible value, which is pi by 2. Everybody processed it. Now, if I take this cos inverse x there, so it will be pi by 2 minus cos inverse x. What is that? That is sine inverse x. And this is sine inverse 1 by 5. Now we know sine inverse is clearly 1, 1 on 2. It was bijective. Then only we could find its inverse. So if it is 1, 1 on 2, sine inverse 1 by 5, sine inverse x. So I can conclude x is going to be 1 by 5 without any hesitation. Everybody got my point. Everybody understood my point. Any confusion, query or concerns? If there are, please ask. Here comes another formula. Give me a minute, students. There we are with this one. Again, this is where students commit mistakes. What mistakes? They often just take this standard one, that if they are told tan inverse x plus tan inverse y, they are often in a rush to write it as tan inverse x plus y upon 1 minus xy. Trust me, you can do this as long as the product of this x and this y is less than 1. What if it is greater than 1? If it is greater than 1, then you have two choices. I repeat, if the product of x and y is greater than 1, now there are two cases. Product is greater than 1, then there are two cases. Either both of them are positive or both of them are negative. Sir, what if either of them is positive and negative? In that case, product will be less than 1. So that case already got covered. So first of all, bifurcation, product of xy greater than 1 or less than 1. If it is less than 1, I'll stick to simple, the standard version. But if it is greater than 1, so if both of them are positive or both of them are negative. If both of them are positive, I'll add pi. If both of them are negative, I'll add minus pi. That's it. That's it. That's it. That's how I personally remember it. Did you understand the algorithm? what did I just say? How I personally remember is that first of all, here we have x and y. So my job is to find the product x and y. So either this product will be less than 1 or this product will be greater than 1. So if the product is less than 1, don't hesitate, just use the standard version. I'm teaching it like an algorithm. Amazing. So I have just developed it while teaching you. So if product of xy is greater than 1, then again you have two choices. Either both of them are positive or both of them are negative. So if both of them are negative, both of them are positive, you add pi to the standard version formula. And if both of them are negative, you add minus pi to that standard version formula. Everybody processed it. Everybody. But sir, what is this formula? How is it getting derived? That depends on you, Techno. How do you treat it? I'm just trying my best. So you tell me, what is your feel? It depends on you. I'm trying to keep it from basics, but you may feel, I mean, that's totally up to a student. It can be subjective. I just cannot comment. I'm trying to keep it from scratch, from very basics. But yes, you can call it a good revision session. I am saying that we remember that set 10a plus b is given by 10a plus 10b whole divided by 1 minus 10a 10b. Remember that? So if I do one thing, what thing? Say 10a if I call x and 10b if I call y. So of course, by using ITF, 10 inverse x will become a and 10 inverse y will become b. So here 10a is replaced by x, 10b is replaced by y, and there it is 1 minus 10a 10b. Yes or no? This is 10a plus b. So a I'm replacing by 10 inverse x, b I'm replacing by 10 inverse y, and whole of 10. So that 10 I'm treating as 10 inverse on the right hand side. I can do so. This is good. This is fine. This is perfectly okay. This is perfectly okay as long as the product xy is less than 1. Why? Because in that case, it stays in that principal domain. I repeat, the product is less than 1. The product is less than 1. In that case, trust me, whatever output this generates and whatever output the LHS generates, they'll stay in sync. But sir, if the product is greater than 1 and if both of them are positive, in that case, the problem is that whatever is generated by LHS and whatever is generated by RHS are not on the same page. Their principal range gets violated. The output does not match. So to balance it out, so to keep them adjusted so that RHS, whatever it produces, stays same to whatever the LHS produces, to ensure that, what I'll do is, I'll add pi to this standard result, which is 10 inverse x plus y upon 1 minus xy. Similarly, if the product of xy is still found to be greater than 1, but if x and y both are found to be negative, if they both are found to be negative, in that case, I'll add minus pi to this standard result 10 inverse x plus y upon 1 minus xy. Getting it or not, everyone? Getting it or not, everyone? Did I confuse you, or are you able to understand the whole concept, the whole formula, the whole versions with the help of this proof? One thing I'm skipping, which we do in a very detailed manner in our Laksh batches, there we explain it properly that why is this pi and minus pi is added. Here I'm not doing it because if I start doing or teaching these adjustments, it will take another 1 or 1.5 hours for me explaining these adjustments. Right now, one basic idea I'll tell you is the approach, where to do what, and second thing, in a shorter manner to do that adjustment. If I could make you recall something, you remember this thing we did here? We made an adjustment. We made this adjustment minus pi. Why did we do it? Because For positive values, output was sorted. LHS and RHS were producing the same output. But for negative values of X, output of LHS and output of RHS were not matching. So I subtracted pi so that it stayed balanced. That adjustment we need to keep doing for all these formulae time and again. That's what I'm saying or suggesting here, if you could understand that. And with this, I'll tell you one of the questions. Through this question, we'll be understanding it more. Shall we do it? What does it say? It gives you two angles of a triangle are tan inverse 2 and tan inverse 3. Okay, so let's call it for a while alpha. Let's call it for a while beta. Then they are asking you to find the third angle. Let's say third angle is gamma. So for a triangle, we know alpha plus beta plus gamma is 180 degree. Yes or no? We know that. Everybody knows that. With that, if I ask you gamma, so what will be gamma? Sir, gamma will be pi minus alpha plus beta. So let's try and work it out. Third angle will be pi minus tan inverse. Alpha is tan inverse 2. Beta is tan inverse 3. Now, before you apply tan inverse x plus tan inverse y, think again. Tan inverse 2 plus tan inverse 3. Tan inverse 2 plus tan inverse 3. The product xy, 2 into 3. 2 into 3 is 6. Is 6 less than 1? No. 6 is greater than 1. And 2 and 3 both are positive. So I'll be using this version. I'll add pi to it. Got my point, everyone? That's a mistake which students commit when they are in rush. They just do tan inverse 2 plus tan inverse 3. Definitely, it's better than that, Hamza. So, pi, my angle will be pi minus pi plus this adjustment is needed to be done so that it stays balanced. And then I'll apply tan inverse x plus y upon 1 minus xy. Getting it, everyone, without getting confused? Are you comfortably understanding all what I'm doing? Or is there any confusion so far regarding anything? Tell me honestly. Did you all get it? Did you all understand it? Everybody? All what I've done so far? So next thing which I'll do is, this pi and this pi are subtracted. So this leaves you with 0 here. So this leaves me with minus sign here. Tan inverse of 2 plus 3 is 5. And 1 minus 6 is minus 5. So this is minus, comes out, plus tan inverse 1. So your gamma is tan inverse 1. 1 I think is 45. That is pi by 4. So remember this. If in a triangle, two angles are tan inverse 2 and tan inverse 3, third angle is going to be 45 degree. Understood it? I hope it was a good question and it made a lot of sense. You were able to process it, yes or no? This question I'm giving you as a homework question, but before I give you this question as a homework question, I'd definitely give you a hint. Sir, if you are giving this question as a homework question, how are we going to retrieve the PDF? It will be uploaded on our WhatsApp channel once the session gets over, and you can practice the questions in this PDF by following our WhatsApp channel. The link is given in the description. Here we are. The hint is, I hope for a while, let's say cos inverse 4 by 5. Although this is how you do it in boards, you don't do it in JEE Mains or Advanced, but in a very childish manner I'm explaining so that the explanation stays simple. So cos alpha will be treated as 4 by 5. So can you help me with tan alpha? Cos is what? Base upon hypotenuse. So this will be a Pythagorean triplet 3, 4, 5. Yes or no? So with this, write this in tan inverse. This is 12, 13. You remember that Pythagorean triplet? This is also 32, 33, 35, 65. So with this, all of these, if you could convert into 10, you would be able to do it with the formula you know in terms of 10. Sir, what if we don't know the formula in terms of 10? Then use the version of cos. But I'll always recommend that instead of learning a lot of formulas, sine inverse x plus sine inverse y, cos inverse x plus cos inverse y, tan inverse x plus tan inverse y, instead of these three formulae, remember one. Which one? Tan inverse x plus tan inverse y. So let's say if you are given this question, it does not take much to convert these into tan inverse. Solve them and get the answer. Will it not be a little easier and simpler? I hope you're understanding. Of course, I'll tell you the other formula as well. I'll tell you the formula for sine inverse x plus sine inverse y. I'll tell you the formula for cos inverse x plus cos inverse y. I will indeed tell you, but I am highlighting the importance of learning one formula, because I hope you are getting this statement that every single formula has its own conditions. And to learn the conditions for tan inverse formula only, we had to build an algorithm kind of a structure. So does it really make any sense that you learn a lot of formulae and remember all the conditions? I'm sure you would get confused. No worries, Satyam. Watch it from the beginning next time. So I repeat my statement very clearly. Instead of learning a lot of formulae, learning a lot of cases, learning a lot of different scenarios, I'll say stick to one and convert other questions into that version and solve it. For example, here, some of you may be doing cos inverse x plus cos inverse y, but again, there you need to apply those conditions or remember those conditions for x and y. Rather, my suggestion is if you could convert it into tan inverse x, tan inverse y, I think your job is done. Getting my point, everyone, all the participants? So with this, homework is given to you. Hint I have given. I hope you can write it in terms of tan inverse. This cos inverse 4 by 5 in terms of tan inverse, I'll be writing as tan alpha. Let me tell you first. Tan alpha, can you help me? Tan alpha? Tan alpha will be 3 by 4. So you will say alpha is tan inverse 3 by 4. This is a very childish way of doing it. If you notice 4, 5 base hypotenuse, for 10 we need perpendicular base, so 3 by 4 will be there. So you could have just done it by, by simply skipping this. Got my point, everyone? Yes or no? Shall I move ahead from here, all the participants? With this, let us solve one more question. This is a very good question, an excellent one. Here, it says tan inverse 2x plus tan inverse 3x is pi by 4. If you just remember one thing we have done, do you remember that? Tan inverse 2, tan inverse 3, pi by 4. Do you remember that relation? So let's try and apply that logic here. In this question, sir, which version will you take of tan inverse? We have learned 3 versions. So which version will you take? In these cases, you don't get worried or concerned about the versions. You simply apply the standard formula. You take the benefit of doubt, and in the end, you verify your answers by pushing those values here. Some of the values will satisfy it, some of the values will not. So the values which satisfy your original equation will be the answer. Great. So what did I just say? Tan inverse x plus tan inverse y is giving you tan inverse x plus y upon 1 minus x y is given as pi by 4. So 10 pi by 4 is 1. This is 2x plus 3x, which is 5x, and this is 1 minus 6x square. So if I take it there and bring it here, I'll have 6x square plus 5x minus 1 is equal to 0. Correct me if I'm wrong. Did I write it correctly? 6x square minus 1 plus 5x. So product I need minus 6, sum I need plus 5. So 6 and minus 1. So 6x square plus 6x minus x minus 1 will be 0, because 6 into minus 1 will be minus 6. 6 minus 1 is plus 5. So with this, if I need you to write the values of x, the values of x we crack as minus 6 upon 6, that's minus 1. Minus 1 upon plus minus of minus 1 upon 6, that is 1 by 6. So 2 values I have cracked. One of the values is 1 minus 1, other value is 1 by 6. Correct me if I'm wrong. Correct me if I'm wrong. I hope we did it correctly. We got the right answer. I mean, minus 1 and plus 1 by 6. Now, one more thing is that now we have gotten 2 answers, but we won't claim that these 2 are my answers. I will verify both of these in this, and I'll check. If they satisfy, then only I'll say. So I'll check it for minus 1, and then I'll check it for 1 by 6. So if I check it for minus 1, it is tan inverse minus 2 plus tan inverse minus 3. Yes or no? So tan inverse minus 2, tan inverse minus 3. They are odd functions. Tan inverse is an odd function. Minus can be taken outside. So I'll be left with tan inverse 2 plus tan inverse 3. I think this we have just done in one of the questions. Great, excellent, Dhruti. That's brilliant. We have just done in one of the questions where I did this thing. Remember that 10 inverse 2 plus 10 inverse 3. So what did I get the final answer? Forget this pi because this is not there. 10 inverse 2 plus 10 inverse 3 is pi plus, and I think this turns out as 5 by minus 5, which is minus 1. So pi minus pi by 4. What is pi minus pi by 4? I hope I'm doing it. I'm just using it what we have already done. So pi minus pi by 4 is 3 pi by 4. So 10 inverse 2 plus 10 inverse 3 is 3 pi by 4. That result I'll apply. So this is 3 pi by 4. So it gives you minus 3 pi by 4 as an output. So LHS is giving you minus 3 pi by 4, where RHS is pi by 4. So this clearly does not match with RHS. So I'll say minus 1 is not an acceptable answer. Excellent. Got my point. Now let's check it for 1 by 6. Let's check it for 1 by 6. So if I check it for 1 by 6, how will I do it? Let me do it. Everyone paying attention here. So I'll check it for 1 by 6 as well. Have patience, everyone. For 1 by 6, 2 by 6 is 1 by 3. So this is 10 inverse 1 by 3. And this is 10 inverse 3 by 6, which is 10 inverse 1 by 2. So 1 by 3, 1 by 2. The product is 1 by 6. 1 by 6 is less than 1. Don't think much. Just apply the standard formula. That will be 10 inverse. Remember that case. X plus y whole divided by 1 minus x into y. Now with this, I'll get 10 inverse. Numerator will have 2 plus 3. That is 5 by 6. Denominator will have 6 minus 1. That is 5 by 6. So that's 1, and 10 inverse 1 is pi by 4, which is RHS. So the only acceptable value is 1 by 6. One answer. Excellent, Himanshi and everyone. I am sure you all are putting your sincere and genuine efforts. Nobody's cheating. Cheating means you are not using AI. That doesn't help. No, Satyam, it's a one shot. I'm not doing it in that manner, the way we did in Laksh, and not that very comprehensive or a very detailed manner where we are understanding every single theorem, every single property, understanding its proof, understanding every single reason behind it, solving a lot of questions. That's not what we are doing here. This session should be treated as a session for revision, for backlog coverage. If you have already gone through this chapter, this should be treated as a revision. That would help you here in a more better manner. Sure, Ms. Himanshi, I'll conduct poll-based questions very soon. Thank you so much for your suggestion. With this, let's do one more question, a very beautiful question, which is asked by JEE Mains a lot. Although I have asked you in a proof kind of a format, but this kind of an AP kind of a structure will be given, and this will be the final answer. So you can remember it as a formula as well, but let's do it. A very beautiful and interesting question it is. I am told in this question that A1, A2, A3, AN are in AP. And the common difference here is D. So we need to prove this LHS is equals to RHS. Okay, let me deal with the LHS. Here, if I deal with this LHS, this 10 stays outside, whole. This 10 inverse, can I write this D as A2 minus A1 upon 1 plus A1, A2? Getting it, everyone? Sir, why? Because this is an AP. So A2 minus A1 will be the common difference, plus 10 inverse. This D, I'm deliberately writing it as A3 minus A2 upon 1 plus A2, A3. If you notice it, you would see telescoping sum. Yes or no, everybody? Now, I'll ask you to recall something based on this standard result only. If we had learnt 10 inverse x plus 10 inverse y, so 10 inverse x minus 10 inverse y, the standard formula without any constraint or conditions will be given by 10 inverse x minus y upon 1 plus xy. Remember that standard result. 10a minus b is 10a minus 10b upon 1 plus 10a 10b. Basic, easy, simple, yes or no? So that thing, if I apply here, 10 stays outside just like that. Whole of 10 inverse a2 minus a1 upon 1 plus a1 a2. Will it not be 10 inverse a2 minus 10 inverse a1 plus? This thing here will be 10 inverse A3 minus A2 upon 1 plus A2 A3 will be tan inverse A3 minus tan inverse A2, and so on. The last term will be tan inverse an minus 1 upon 1 plus an minus n1 will be tan inverse an minus tan inverse an minus 1. Any confusion so far? Please ask if there are any doubts, queries, or concerns. Shall I move ahead from here, all the participants? Everybody with me so far regarding anything, whatever I've done so far? Tell me. Satyam. Thank you so much. I think this is Jack, the Jack of our class. Himanshi is behaving like Jack. Jack is one of the students, Himanshi, who studies in our class. His name is, actual name is Balaji. Satyam, tell Balaji about this, that I mentioned him in one of the live classes. He also behaves like this. Instead of focusing or studying, he keeps on complimenting or coming up with a lot of comments. Anyways, keep it up. Good. So I am trying to tell you here that look at the pattern. Sir, what pattern? This term is cancelling this term. So first term of this term, now Satyam, don't get involved. You also stay focused. First term of the first term is cancelling the second term of the second term. Are you understanding my language? So this will cancel the second term over here. Everything will get cancelled. I hope you're understanding. This thing will get cancelled from the first term of the second last term. If you could notice the pattern, VN method, telescoping sum, if you could apply. So I'll technically be left with two things, tan inverse AN and minus tan inverse A1. So if I could simplify this, I have 10 outside. What did I do? I have 10 outside. And inside this, I have tan inverse of AN minus tan inverse of A1. So again, if I apply the formula, tan inverse of x minus y, so an minus a1 whole divided by 1 plus a1 an or an a1, whatever you wish to write. So you can take this benefit of doubt. Tan and tan inverse will nullify each other. An as per AP is given by first term plus n minus 1 into common difference minus first term. Remember that basic thing. Nth term of an AP is first term plus n minus 1 into d divided by 1 plus a1 an. I think a1 are cancelled. Finally, what am I left with? I am left with n minus 1 whole times d whole divided by 1 plus a1 an. Everybody got it? Everybody understood it? Are there any confusions, queries, or concerns? If there are, please ask. Come on, you guys. Both of you. Had you been here in an offline class, I would have slapped both of you. I mean it. Come on, study properly. If you are genuinely studying, both of you, come on, stop it now. Good, Himanshi, keep it up. But now let's study, everyone, both of you, and all the other students who are learning or wanting to understand sincerely. Everybody got it? Everybody, yes or no? So these ones I'll not be explaining. I'll just give you the idea that how do they get derived. So do you remember sin A cos B plus cos A sin B is sin A plus B? But again, an adjustment is needed to be made. If the condition is this, you subtract it from pi. But if the condition is this, you just write it like this. Why? I explained it in a more proper manner in Laksh batch. But right now, let's just keep it like this. Sir, how are we going to remember all these different variants? I would say no. Just remember that tan inverse version and its variants, its different ways. Sir, what if we see a question on this? Then you know how to convert sine inverse into tan inverse, and then apply tan inverse formula. Will that not be more easy or more easier? Yes or no? The same you could do on cos inverse as well. Everybody getting it? Everybody getting it? Everybody comfortably understanding it? Yes or no? All the participants. Has everyone understood it? Shall we try some questions in that case? This question I'll give you as a homework question. I'll ask you to apply it or do it with the help of a hint. Convert this into 10. You know how to. Convert this into 10. You very clearly know how to. And you will very easily be able to get this answer. Trust me. So I'm constantly asking you to learn those formulae. Let's solve this one. If I wish to solve this question, how will I solve this one? There are multiple methods. One of the best practices I should have followed is that, remember that condition that here we have learned that sine inverse x plus cos inverse x is pi by 2. So this cos inverse x over here, this cos inverse x, this remains as sine inverse x. This remains as sine inverse 1 minus x. This cos inverse x, if I substitute by pi by 2 minus sine inverse x, are you okay with this thing, whatever I've done so far? Now the next thing which I do is sine inverse x, if I bring here, sine inverse x will be 2 times sine inverse x, and this here, if goes to the other side, will become pi by 2 minus sine inverse 1 minus x. Everyone comfortably getting whatever I'm doing or suggesting or saying without any query or confusion? Now you have two choices. So what two choices? One of the ways is I take sine ratio on both sides. Other method is pi by 2 minus sine inverse 1 minus x. I write as cos inverse 1 minus x. Which would be better? Let's write it as, first of all, pi by 2 minus sine inverse is cos inverse. Remember that. So this thing I write as cos inverse 1 minus x. This is 2 sine inverse x. Any doubts, queries or concerns so far regarding whatever I've done? Everybody comfortably getting it? Now what I do next is, let's say sine inverse x. Cos inverse 1 minus x. So if I take sine ratio on both sides, but still I'll get stuck. So I have a lot of methods in my mind. I'm just thinking of one of the best methods. By the time I'm focusing there, a lot of comments are, I will get both of you blocked so that I can focus on teaching. Give me a moment, students. Here we are. So I'll say sine, I'll take sine ratio if I take on both sides. If I take sine ratio on both sides, it is 1 minus x, right? It is 1 minus x. Okay. I could have used that version as well, that sine inverse x plus sine inverse y. This formula I could have used. That formula also would have been useful, but I think this is also good because ultimately cos is what I'm dealing with. I'll do it with that approach as well. Don't worry. I'll keep it reserved for that approach as well. Don't worry about that. But let me complete it with this approach and then I'll apply that approach as well, the standard version. So here, if I take sine ratio on both sides, so it will give me sine of 2 sine inverse x, and this will be sine of cos inverse 1 minus x. Any confusion so far? Any confusions or queries so far? Or what if I take cos? I think that would have been better. So if I take cos, so it will be cos of 2 times sine inverse x, yes or no? And this will be cos inverse of 1 minus x. I hope this works better because that's where I'll get the opportunity to get it nullified. So here if I solve it further, what I'll do next is I will consider sine inverse x as theta. So if sine inverse x is theta, without any doubt, sine theta is x. Sine theta is x. So this thing here is on the LHS is cos 2 theta. Give me a moment, students. Let me just rewrite it here. This thing cos 2 theta, because sine inverse x we have taken as theta. So this is cos 2 theta. Everybody getting it? Cos and cos inverse are nullified. So I'm left with 1 minus x. And what is x? That's sine theta. I hope everyone comfortably getting it without any hesitation. Now with this cos 2 theta has 3 variants or 4 rather. So I'll use 1 minus 2 sine square theta. So this is 1 minus 2 sine square theta. This is 1 minus sine theta. 1 and 1 are cancelled. Minus and minus is cancelled. So I'll say 2 sine square theta is equal to sine theta. Everyone comfortably understanding this? So sine theta and sine theta are cancelled. You don't cancel a variable by a variable, but if you do so, you need to consider that variable to be 0. Otherwise, root loss will happen. Then I'll have here 2 sine theta is equal to 1. So that concludes sine theta as 1 by 2. Sine theta was originally x. So I have gotten two values of x. Which two values of x? I have gotten x as 0 or 1 by 2. So we get x as 0 or 1 by 2. Now again, don't believe that both of these could be my acceptable values or acceptable answers. What I need to do here is I will test 0 first. So sine inverse 0 is 0 plus sine inverse 1 minus 0 is sine inverse 1, which is pi by 2. And cos inverse 0 is pi by 2. So 0 gets satisfied. It is perfectly fine. Now I'll try 1 by 2. Sine inverse 1 by 2 is your 30 degree. Getting it, everyone? Sine inverse 1 by 2 is 30 degree, which is pi by 6, plus sine inverse 1 minus 1 by 2, which is again 30 degree, which is again pi by 6. And this is cos inverse 1 by 2, which is 60 degree, which is pi by 3. So this is also true. So 0 and 1 by 2, both are my acceptable answers. Both are acceptable answers, Dhruti. So I hope with this you can develop two sine inverse x as well. How? Sine inverse x plus sine inverse x. Yes or no? That gets developed. And similarly, 3 sine inverse x can be developed. Similarly, 2 cos inverse x can be developed. Similarly, 2 tan inverse can be developed. I hope you will try these questions by yourself. And we are done with this session. I'll not ask you to memorize a lot of formulae, but I'm sure you must have understood all what is explained in this session. Excellent. What is my request now? If you have watched this session, most important thing is solve PYQs. Begin with mains PYQs. Solve all the PYQs since 2020 onwards. Once you're done with those, solve advanced PYQs and solve all the PYQs after 2000. That's what you need to do. Any other concerns or queries if you have, please ask. Otherwise, we'll call it a day now. Exactly at 12 o'clock, we are ending this. Amazing. Beautiful. Shall I call it a day? Everyone, shall we end this session here? Yes or no? Shall we end it now, all the participants? So, there are no doubts, queries, or concerns. I'm ending this session. Thank you so much, everyone, for your patience, for your comments, for your response. Those sincere ones who are participating actively, good, keep it up. That's how you learn. That's how you get better. So I'm sure all the participants who are genuinely wanting to crack IDJ are enjoying this series, are learning a lot from this series. And with this, let's meet with the next chapter in the next class. I think I'll be bringing LCD, limits, continuity, and differentiability. Shall we end it here? Did you all learn and enjoy? So let's call it a day. Thank you so much. You have been a great audience. Take a good care of yourself. Good night, everyone.